Hello and welcome to the 84 Million podcast. Today we have as our guest Mr. Clemens Ley of the Litecoin Computer. Let me introduce him for us. Clemens Ley has been building practical smart contract systems for Bitcoin and Litecoin since 2018. He's the inventor and founder of Litecoin Computer, a Turing complete smart contract system for Litecoin. He's a computer scientist and holds a PhD in database theory from Oxford University. Follow him on X at Clemens Ley. So, Clemens, it's wonderful to have you this evening.
Thank you very much for having me.
Okay, good to see you. You know, the last time I think we were speaking, we were in Nashville just about 4 weeks ago, and we were on, I want to say, the fourth floor of the Margaritaville Hotel and Resort for the Litecoin Summit. And we spoke of having you on prior, but with us getting to Nashville, we had to postpone. And of course, you gave a presentation there. We got to chatting on the roof. And of course, it was great seeing Laura as well and hearing about you and getting to know you, the man, sort of. But I did want to bring you on the show. I'm glad that you're here. We want to talk about the Litecoin Computer. But maybe before we do you have anything to reflect on Nashville or the Litecoin Summit?
Yeah, I mean, it was fantastic, the Litecoin Summit, in my opinion. So just like, I mean, the quality of the presentations was just off the charts, in my opinion. So I went to the Litecoin conference and the Bitcoin conference, and I probably shouldn't say this on the internet, but to me, the quality of the presentations on Litecoin conference was way better than on the Bitcoin conference, like the average presentation or something. So I really enjoyed it, and it's a fantastic community, the Litecoin community. I met a lot of people that didn't know, and it was very, very interesting. So it was absolutely worth the hard travel. Yeah, it was great.
Well, it was terrific to see you. And you were at previous summits, 2022?
Yeah, at 2 years ago. I think it was in Las Vegas. Yeah, that was.
I think that was 2022. And then I think they did the cruise, which doesn't really count as a summit. And then, of course, the Nashville summit right down the street from Bitcoin. So I didn't know you went to the Bitcoin conference or the Bitcoin Nashville, I think is what they were referring to it as this year. Tell us about that. And maybe go a little bit on that. I'm cool with that. What was the difference?
It's a very, very sort of different vibe. I mean, so obviously the size, the Bitcoin conference is much bigger, and you have like all these parallel tracks and stuff like that. But in terms of, I mean, at the end of the day, people don't go to these conferences for the talks because all the talks are online. You can just watch them online. You go there to like talk to people and meet people and stuff like that. And also like in that regard, just like being like a smaller format and like this, very open, friendly community. I met more people at the Litecoin Summit than at the Bitcoin Summit. But then obviously, the Bitcoin Summit was also incredible. Just like, all these politicians that you can like see live, speaking, and then all these famous Bitcoiners, and you can just like, some of them just walk up and strike up a conversation. So, I mean, both were fantastic events. I'm very, very happy that I went, and I'll definitely go in the future.
That's impressive. Yeah, it's interesting that RFK and Trump were there. And of course, this is not a political podcast, but they're both very pro Bitcoin. And I think Tulsi's been pretty pro blockchain too, in some degree, to some degree, or in some ways. And they're all kind of banding together now, which is pretty fascinating. But again, we're not here to talk politics. We're here to talk about the Litecoin Computer. But the summit was great. To be honest, I miss it. I think we had a really nice 2 days, and I look forward to the next one. So I think they're talking about a cruise in January, maybe. But anyway, let's move forward here with you, sir. So Litecoin Computer, I think it's somewhat complicated, but that's because I'm coming from it I'm not a programmer, I'm not a coder. Yes, I use computer systems. I've used them since I was, in third grade or something. I think the first one was, I don't know, you're still operating in a DOS environment and command lines and things like that. Those things have come a long way. But tell us maybe about the Litecoin Computer. And just for our audio and visual friends, this is going to be more presentation-based perhaps than normally on this show. And I think that's totally appropriate because I think Clemens is the one we want to hear from versus me. He's the pro here. He's the guy building this. He's the mastermind. So I'm just going to let him kind of present. I may interject here and there to provide maybe a point of clarity or something like this, or ask him things. But I'm going to basically let him go. And I've got a few questions for him at the end. But I look forward to this. I know, I think y'all will too. So I think it's really great that of course you, sir, Clemens, with us, that you're here on the show with us today. So if you want to maybe share your screen and we'll get going.
All set.
We're good to go. Yeah.
Super. Right. Okay. So this is the same, almost exactly the same presentation I gave at the Litecoin Summit, but there's some bonus content because, Kyle and I talked about the fact that probably many listeners of the podcast are not programmers. And sort of as a little bonus content, I want to sort of break down just the very basic principles of computation and programming. And that will sort of, hopefully make it clearer, set up some context for not just how the Bitcoin computer works, but how different, smart contract systems for Bitcoin actually work. So I jump right in. So the content was, produced in collaboration with my co-founder, Laura. And so what we're going to do is we're going to sort of try to give a classification of different smart contract systems for Bitcoin. And so we're not so much interested in the individual system. We're just more interested in the classes, and you can see them listed on the left side. And then we're going to try to sort of compare all these classes according to 3 different metrics. The first one is the most important one, in my opinion, is the question of trustlessness. So that's just the question: can you interact with these smart contracts, or more concretely, an application using those smart contracts without having to trust, some third party? And this is obviously a very important point because this is arguably just the entire point of the blockchain endeavor. So sentence 2 of the Bitcoin white paper states that the main benefits are lost if, a trusted third party is required for the system to work. Mm-hmm. So that's an important point. The second one is this question of expressive power. That is just a question of how many applications essentially can be built in the smart contract system. And this is where this term, Turing completeness comes from, which essentially just means anything that can be computed, a system is Turing complete if anything that can be computed in any system can be computed in that system as well. And sort of the third metric is efficiency, which I'm sort of here formalizing. Maybe I have to refine the formalization a little bit, but is it possible to compute a value without reading all of the transactions, right? And so obviously, if you have to kind of sync a node, if you want to find out anything, if you're interested in just how many tokens does this specific user have, right? Ideally, we'd like to be able to do that without having to sync the entire node, up till that point. Mm-hmm. And so we're going to get started. So what we want to do is we want to fill in this table here, and we have kind of all the classes of smart contract systems on the left, and our 2 properties at the top, right? And sort of just to set some context, I've added Ethereum to this list here at the top. All right, and so for Ethereum, we already kind of know the answer that it is trustless, right? I mean, so arguably you're trusting sort of the miners, but Ethereum is considered, a trustless, blockchain. It is expressive in the sense that it is, Turing complete, and we'll not get sidetracked by minor details. Ethereum is just mostly Turing complete, and but the questions of efficiency is unfortunately sort of the answer is negative. So if you want to know what is the account balance of a certain address, in reality you kind of have to sync a full node, right? So again, all these questions are not so clear cut. People could kind of argue about light clients and simple payment verification, but there's this whole other can of worms or problems regarding light clients. So typically, if you want to know any piece of information of the Ethereum blockchain and you don't want to trust anyone else, what you have to do is you have to sync a full node, you have to read and parse every single transaction, and you have to execute every single smart contract that has ever been broadcast to Ethereum. I
do have a question here.
Yeah.
And by the way, friends, Clemens can't see me, so I might sound really rude when I interrupt him, but it's the way we kind of have to do with the way we're sort of set up here. But 2 questions. It's just for me personally. I don't know if anybody else has a question. Can you define what Turing is? And the other thing would be with Ethereum, maybe tell us what that is in the event somebody on the show doesn't know what Ethereum is or how it works or why it was created versus Bitcoin.
Yep. Yeah. So, I mean, so Turing is the name of a researcher called Alan Turing. And this notion of Turing completeness was sort of arguably sort of invented by him. And so Alan Turing lived obviously before we really had computers and hardware. And so this was all sort of just theoretical work. But he invented this very simple mathematical model called the Turing machine, right? Which is really a very, very simple kind of just machine. It has access to a tape of unlimited size. And then what it can do in every single step, it can, inspect one cell of that tape, and it can, it stores some finite amount of internal state. And then it can sort of, look at the current symbol on the tape and compare it to the local state. and then make a decision to change that symbol, right, and move its head to the left or to the right. So it's a very, sounds a little bit obscure now, but it's just this very simple computing device. And sort of the question was, is there some other definition of a computation device that can accept more languages than this Turing machine, right? And nobody knows the answer until this day, right? Because any day anyone could invent some hypothetical machine. But since Alan Turing's work, nobody has been able to sort of create a machine that can actually express more, right? So there's other people like Alonzo Church invented the lambda calculus, which is a very different definition, but it can express exactly the same programs. So this is what led to what's called the Church-Turing thesis. This is the thesis that Turing machines can express all possible programs that can be expressed in any formalism, right? And it's just a thesis, but it's sort of the short version of that is it just sort of encompasses all programs that can be computed by any possible machine.
Okay.
And and then Ethereum. Let me give an explanation for Ethereum when we talk about these block order-based smart contract systems for Bitcoin. It'll fit in better there.
No problem. Sounds good. And I think, as far as I know, general users don't run nodes for Ethereum. Am I wrong?
Yeah. Well, general users don't run nodes, and they trust the node operator, right? So they just ask the node operator, what is the account balance in this account, and then they just sort of trust the node operator. And that's a big problem, because if you think of applications, these smart contracts on Ethereum, they always require, some server that can run the node. Right. And if you think of any servers that you're aware of, users don't run servers, users use web browsers, and operators use servers. So executing smart contracts server side essentially just recreates the current model of Silicon Valley, right? What is the problem in Silicon Valley? That we have like all these big tech companies, they run their servers and they have all the power, right? And sort of smart contracts are sort of this opportunity where, to redistribute some of that power back to the users, right? So that users could actually verify things themselves.
Right.
But if users don't run nodes, then, again, a lot of the benefits of just blockchain are lost. So I think the argument is pretty much, you could run a node, right? Mm-hmm. You could pay that money and verify that the operator always did the right thing. But in practice, most smart contracts just go unverified pretty much.
Yeah, and I know on Litecoin, we all can run a node, even in terms of, how much space do we need to sync the entire blockchain in its history, going on 13 years, is not that demanding. So a lot of us are Litecoiners here. Probably everyone's heard of Ethereum, maybe not. Again, we're going to explain it for the one person who doesn't know what Ethereum is, which is why I'm asking you. But I think sometimes we take nodes and the decentralized node and that every user can run a node for granted, when the fact is a lot of cryptocurrencies don't even offer that, including a big one like Ethereum. But back to you, sir.
So just to be clear, so users can run nodes, right? You can just download it. It's open source software. You can download it and sort of run it, just like you would a Litecoin node. But I'm just saying, in practice, most people that buy NFTs on OpenSea, for example, mm-hmm. typically don't run a node. They just visit a website, right? And the website will tell them, which NFTs they have. And then if they wanted to, they could run a node, but most de facto just don't.
Is it common to run a node in Ethereum, though? When I talked to David BURKETT on episode 1, he was suggesting that people aren't running nodes, or you don't run a node in Ethereum. So that's new to me. I didn't know you actually could run a node.
So you can run a node. It's just like, it's like, technically, it's a little bit expensive. It's not that expensive. But mostly the problem is that it's just technically hard, right? You have to deal with compiling. To be honest, I'm a pretty technical person.
Yeah.
And I've not run, nodes many times. I have hired people that run nodes for me, but it's quite complicated sometimes.
So that's pretty inaccessible to most people then.
Yeah.
Yeah. Okay.
And this is where there is actually an opportunity. So we'll talk about it later on Bitcoin. There is this notion of client-side validation mm-hmm. that sort of flips the script, where instead of the operators executing the smart contracts, the end users execute the smart contracts, right? And this is a much, much better guarantee to trust users, because they literally just verify, the smart contract themselves.
Okay.
Yeah. All right. Okay, so we can sort of get going with just sort of a brief history of, these different types of smart contract systems that have been proposed in the past. Okay, so there's the interoperable blockchains, right? So examples are, Stacks, the Internet Computer, or, Bob built on Bitcoin. And what these really are is just like a separate blockchain, right? That is sort of loosely connected to Bitcoin in different ways. For example, sometimes they can read and write to the L1, right? So you have a separate blockchain, you can execute a smart contract there, and if that gets executed, a transaction is broadcast on the Litecoin or on the Bitcoin chain, right? And then in some cases, like in the case of stacks, for example, the level 1 asset, is used in the consensus algorithm of the L2, right? But it's still just a completely separate blockchain, separate data structure. There's a different node software. If you wanted to verify it, you'd have to, run both the node for Litecoin and the node for stacks if you want to access it trustlessly, right? And then if as an end user you wanted to use it, the thing is just to use the smart contracts on the L2, you just need that asset, right? And the only way to get that asset is to just go through an exchange and, buy, the stacks token there. And then using your stacks token, you can now send, transactions to the interoperable blockchain. And if you want to, exit the L2 ecosystem, you would go back to the exchange and, get this L1 asset, right? And this is like not a terrible approach. And this is kind of like, this is just like all blockchain, but frankly, just with the added, integration that you can read and write and interact with the L1 in some ways. But then if we look at it from our, 3 metrics, so, I mean, it depends on the L2, but typically they are expressed. Typically, the L2 is kind of a clone of Ethereum in most cases. So you can do all smart contracts. It's just as efficient or not as Ethereum, but sadly, it's like not trustless, right? Because these exchanges are typically, centralized. So you have to trust your operator when you send your Bitcoin there that they will send you the L2 money back, right? And also like, trustlessness is noticeable by the user in terms of just user experience, right? So if you say you wanted to build an application based on these things, you first have to ask your users, now go to this exchange, probably KYC there, right? There might be some time until you get your money. And so it's not a great user experience, and it's also kind of not trustless.
Right.
So still, cool. And okay, so then historically, I think sidechains were actually even invented before these interoperable blockchains, right? So the main examples are Liquid and Rootstock. And so this is a separate blockchain that's somehow more tightly connected to the L1, right? And the way it works is if you want to use the L2, you send your Litecoin into the custody of, some group of users called Federation, right? And typically you don't know who these users are, but you're just like trusting them to hang on to your Litecoin, right? And then they will send you your L2 asset and or like mint that on the L2. And then when you can use the L2, and when you want your money back, you have to go back to the Federation, and then hopefully they will give you your money back. But sort of again, the question of efficiency and expressive power depends on the L2. But the important property of trustlessness, obviously here you're just trusting your great Litecoin with the Federation, and they give you some token that they can mint for free.
Right.
So that's like way less trustless than just using L1 Litecoin for sure.
A question about trustlessness and layering. Layer 1 with Bitcoin or Litecoin, we think of as trustless. And it's been said that all layer 2s are abandon trustlessness or, require trust. Would you agree with that, or is that an incorrect statement?
So was one sort of impractical exception, I agree with the statement, right? So we'll look actually on the next slide. We'll see that there is, when it comes to rollups, sort of the third class of these, typical L2s are rollups, and they come in 2 variants, and then the second variant has a sub-variant, and that sub-variant is very expensive, very impractical, but, in theory, sort of trustless. Okay. But in practice, I mean, let's just talk about it. These rollups are in practice also just like not trustless.
Okay.
Right? So I sort of now argued why, sidechains and interoperable blockchains, why they're sort of, not as trustless as the L1s. So let's look at rollups and see how they work, right? So they work similar to sidechains, right? But now we make it actually more decentralized. It's definitely an improvement over sidechains, because what we do is we replace this federation that would just hold onto your Litecoin is replaced by a smart contract on the L1, right? So that's something to digest right there. So the first observation, just reading the sentence, is that rollups aren't like some magical tool to make smart contracts appear on a blockchain. They sort of rely on the smart contract capabilities of the L1 already, right? And sort of for that reason, okay, let's just walk through how it kind of works.
These are the ZK snarks versus starks. Is that what we're referring to?
Exactly.
Or? Okay.
So on the next slide, I'll break it down. They have these optimistic rollups and the zero knowledge rollups, and then you can see these subclasses of the zero knowledge ones are the starks and the snarks. But we'll get to that. First, I want to give you sort of a high level view.
Yes, please do, because I know nothing, and this is not for me. This is for everyone.
Yeah, and this is esoteric stuff, and it's very hard. It quite frankly, it took me quite some time to break it down in simple terms. It's very hard to research kind of this information, in my opinion, because you have to chew through pages of marketing stuff, and some of these white papers are just a lot of very, very bad signal to noise ratio. But that was kind of the goal of this talk, to just make it really easy to understand and how these things work from 10,000 feet. I think you can learn a tremendous amount of stuff about computer systems, but just looking very high level in an abstract sense from 10,000 feet. All right, let's do this for the side chains. All right, so the side rollups, are like side chains, just this trusted federation is replaced by a smart contract on the L1, which sounds like a great improvement. And so the way you would do it is you would send your assets that you want to use on the L2 into a rollup smart contract on the L1. Okay, and then to use the L2. So now one big difference between the important point at the second half of the sentence here is that so not only do we replace the federation by a smart contract, but also we store all the data on the L1, right? And sort of this has kind of pros and cons. The advantage is about data availability, right? So since all the smart contract data is stored on the highly secure level 1 blockchain, the data availability is as good as for the L1. That's the advantage. But the disadvantage is that now we don't really have some sort of decentralized group of people who we can send our transactions to, right? So if you think of these other two examples, we have this, we have the main L1 chain and we have the L2 chain, and the L2 chain is a normal blockchain with proof of work or proof of stake. If you want to use it and you have the asset, you just send a transaction, into this decentralized network of miners or validators. But now we don't have any second blockchain anymore. So there's no decentralized group of miners that we can send our level 2 transaction to, right? So instead, there is typically, for every L1, there's one aggregator, right? And so you should think of this, okay, and this aggregator evaluates all the smart contracts for everyone, right? So the way it works is you want to play a game on this L2. So you send the next move in your game, the transaction with the next move in your game, to that one aggregator, right? And then that aggregator will then evaluate, that instruction for you, right? And so specifically what the aggregators do, they wait for a little bit and then they batch together a large number of transactions and evaluate them all in one block. And then what they do is they store these L2 transactions back to the L1 blockchain, like we said before. All the transaction data lives on the L1, and you have to pay the L1 fees for that. But in addition to just the transactions, they also store the new states on the level 1 blockchain, right? And so we don't want to get too detailed here, but they essentially kind of make a statement saying, okay, I evaluated all of these transactions, right? And sort of all the new balances now are like this, right? And they don't have to literally enumerate all the balances. They just store the hash of all of those balances. Okay, and then there's different ways. Now you disappeared. I hope you're still here.
I'm still here. Yeah, you're good.
So the user sends their transaction to the aggregator, who will then sort of evaluate their transaction and publish all the transaction data on the L1 and also the hash of the new state on the L1. And now this level 1 smart contract guarantees that the evaluation is valid, right? Since there's just one guy evaluating all these smart contracts now, that guy could just lie and just say, well, everybody else lost their games. I won all my games. I own everybody's tokens, right? So there must be some mechanism to kind of check that. And then there's different ways to guarantee that the execution is valid. And this will be the optimistic and the other and zero knowledge rollups that we will look into the next slide. But just kind of to wrap this up, when you want to get your Litecoin back, you're done playing your games on the sidechain, on the rollup, and you want your money back, then you send a withdrawal request to the aggregator, and they will then give you this this level 1 asset, right? And sort of really any questions at this point, maybe?
Well, I think it's interesting. So with something like Liquid, you're and that's for Bitcoin, a sort of a privacy second layer privacy or sidechain. You're trusting the federation to peg in and peg out. I think that's the right language, and they're the gatekeepers and they permit you to do it. With something like this, you're dealing with a smart contract doing the same sort of governance, but rather than people, it's code. So it's either I'm trusting a group of people, decentralized to a degree, but not nearly as decentralized as a layer one, or I'm trusting a code setup. I would imagine there's pros and cons to either one of those.
Yeah, for sure. Yeah. I mean, so mostly rollups, have an advantage over sidechain. So, I mean, I guess the only con is that they're much more complicated to program, right? And obviously, with all this complicated stuff, there come, opportunity for bugs and stuff like that. But from a trustlessness point of view, it's definitely a big step up from sidechains, right? And so I should also give, credit is due. These BitVM guys, these are very smart people, right? And they've done an amazing job. I mean, it's just like this combination of several really very novel ideas that they sort of could combine in a great way to build something that people always thought was impossible on Bitcoin, right? So despite all my criticism, these are great people that have built this.
And you're talking about doing anything on Bitcoin other than monetary transactions.
Yeah, exactly. Yeah, and well, specifically this one very specific program of a rollup. Right, but then to sort of rein in the optimism again a little bit is that there are problems with these rollups even on Ethereum, right? And so like I said, sort of how well smart contracts work in practice depends a lot on the smart contract capability of the underlying blockchain, right? So if you have a very rich computing environment there, then you can pull all the tricks and make a very very easy to use system. If you're in the case of Bitcoin, it's very complicated to actually perform computation, then obviously you have a harder job, it's more complicated to program, and probably the usability will not be quite as good, right? And so the way this talk is set up a little bit is, since these rollups on Bitcoin are still very new, right? And they're all, several great teams working on it, and they're all under development. I kind of looked mostly for this talk on rollups on Ethereum, because I kind of know that rollups on Ethereum will tell us how good it could possibly get on Bitcoin, right? It's just they're way easier to implement on Ethereum. So maybe we can be sort of as good as the ones on Ethereum, but there's no way we could be better, right? Because then you could just do it on, and most likely will have slightly longer lockup periods and be a little bit less user friendly than the ones on Ethereum, right? But then by sort of looking into how that works on Ethereum, we can kind of look into the future a little bit. How good can this get on Bitcoin, pretty much? Right.
Noted.
So maybe now we're ready to dive into the details of really this question of how the smart contract guarantees that the evaluation was valid,
okay,
right? And how it is guaranteed that the aggregator specifically cannot lie, right? So that's the big question. And there's two basic approaches. They're called optimistic and zero knowledge, right? And so in the optimistic case, the basic assumption is that the aggregator does not lie, right? So the aggregator just goes ahead. Nothing's computed on the main chain, and they just publish their, their transaction data and their state root. And the basic assumption is that the aggregator didn't lie. But then, to make sure that he actually didn't, there's a second group of users called validators. And they can now redo this computation that the aggregator did. And if they find that the aggregator lied, they can publish what's called a fraud proof that would prove that, the aggregator lied. Okay, and then if the fraud proof is correct, so the aggregator lied, the aggregator is fined. And but the opposite can also happen, that the validator made a mistake or did something malicious. So if the aggregator sort of claims, if the validator claims, aggregator lied, the aggregator actually didn't lie, that's a bad thing. So in that case, the validator is fined. Mm-hmm. Right, and sort of now we can kind of look a little bit into validating what's happening here. So number one, if we see the word find, we already know that some money must be somehow tied up or staked or something like that, right? Someone needs to kind of put down the money to otherwise you can't take it away from him in a blockchain setting, right? And so usually what this leads to is sort of high capital requirements. If you're trusted with $1 million, you have to put down $1 million, because if you steal the $1 million, you have to take your original $1 million away or something like that, right? And so that's one problem. But the bigger problem is actually in the incentives, in my opinion, right? So the aggregator right? So I think as far as I'm aware, like all the big rollups on Ethereum, all big optimistic rollups only have one aggregator right now. There's no real reason. I mean, technically, I think there could be multiple aggregators, but maybe there's practical problems. Maybe it's just like a business kind of thing. But these are like big companies, right? So you should think of them as like more like a cloud computing company than like a Bitcoin miner, right? Because they evaluate everybody's function calls, right? And so they really kind of perform a similar, function to just like Google, right? What do you do, if you use like Google Cloud Documents kind of stuff, essentially what you do is you send them update requests, insert this letter into this document, and then Google will go ahead and insert that letter, right? And, Google might lie, maybe you'll type in A and it'll just print in B. There's nothing you can do about that in the case of Google. That's kind of the advantage sort of these rollups, is that now you do have these validators that can kind of check if Google did the right thing, right? If Google, just, performed all the computations as specified by the users.
Unfortunately, I have to say that Google does lie regularly, because when I type in Litecoin, it autocorrects to Bitcoin, and that needs to be changed. Sorry, I digress.
I could talk like an hour about that. I didn't say Google search is.
You'd think we'd be beyond this by this point.
Yeah, exactly. Yeah. So there's an advantage, right? And then, okay, but what are, how does the economics of this kind of stuff work, right? So there's one aggregator, multiple validator. The aggregator, they get all the level 1 fees, right? And level 1 fees are very, very big on Ethereum, right? So there's a good study by Van Eck, which is some investment company from New York.
Right. Yeah.
And I think they said that these validators typically make like tens of millions of dollars in revenue per month.
Wow.
So probably, I mean, if they make like, $10 million in revenue, right? They want to make $1 million in profit. So then probably their computation takes like $9 million, right? And they make $1 million in profit, and I'm pretty happy every month.
Yeah.
But now if you want to validate that computation, you have to perform that, computation that just cost $9 million, right? Wow. If you wanted to validate the entire month, say, right? And then, maybe the outcome might just be, well, they actually didn't lie. So they just took like $9 million adding anything. So that's like a very bad incentive, right? And you would think that the risk here is that there's just like not so many validators around, right? And sort of you're sort of as an end user, you're just like relying that there are app validators, but you don't see them. They don't post anything anywhere as far as I know, or maybe it depends from system to system. But in general, they're sort of relatively invisible. But actually there's a website that I found to back that up. You see, if you still see my
Yep,
screen?
we see it. Yep.
This is a very cool website, L2Beat. This gives you tons of interesting things about all things L2s on Ethereum, right? I don't know if they've added Bitcoin yet, but then you can go here to ZK catalog, and it gives you more information about like all these rollups pretty much, right? And in addition, they show you the number of verifiers, right? So you can already see this list of existing smart contracts for Ethereum. Like each one has single-digit number of verifiers.
Yeah, there's not
right?
a lot. Yeah.
You can click on this thing here and see, okay, well, this verifier was last seen 2 days ago, right? And this guy was seen 84 days ago.
Mm-hmm.
These guys are kind of not around, right? So even though it kind of looks here, this one, they don't even know, right? So even though they put the number 6 here, in this case, I mean, really, you can hope that the guy that was performing that expensive computation 2 days ago, but they're still, you don't know, right? And then this is kind of the best one, right? And then like these, you can just kind of all this stuff's not verified. Nobody really kind of knows how many verifiers there are, right? And like all of these cases, 64 days ago. So if there's no validator around, these rollup operators can get away with
anything,
and no one noticed. And now the worst part of all of this is that what has happened is that like these validators. I'm sorry, the rollup providers, they had to pay sort of very high fees on Ethereum, right? Because they had to dump like all this data on Ethereum and stuff like that. So they introduced something in Ethereum called blob space, which radically reduced the cost of data storage specifically for rollups on Ethereum, right? And you can actually see it here. I should have found that place. This is the same company, Van Eck. They're doing this L2Beat thing. That's how I found it. Yeah. And they're sort of tracking. They have this chart here. I should have prepared that. About the revenue with the introduction of this cheap storage here. This is data publishing cost according to Ethereum, right? So what happened is they introduced here in like March 2024, they introduced this new blob format, And you can see that like the cost for these L2s went way down, right? And so, but what this kind of means is that like just like sort of the revenue for the miners has just completely disappeared, right? And because the L2s can now all push their data into blob storage. But the worst part about blob storage is that it gets deleted every couple of weeks. There's somewhere here only before deletion. So this data gets stored for 4 weeks. So if some rollup operator got away with lying, right, and none of these guys were online at that time that he posted that batch of transactions,
which could have happened, with what we're seeing. Yeah,
there's nothing you can do anymore, right? It's just like lost in time. It's been deleted from the blockchain, and so if you I guess it sounds like advertisement to do bad things, but like
no, fair enough. Like what informed that parameter, and like we can literally see this oversight page you're showing everyone, and these folks aren't even online.
Yeah, it's crazy.
Right, and then this guy has just one. It's never been seen. I don't know what read. This doesn't look too good. Probably answer. Doesn't verify. Like, and this is literally all of it. This looks good. WorldCoin. Oh, this is these dudes. All right. Okay. WorldCoin has it down. Right. They have like 5 validators, and they've all been seen today. Nobody knows what time, but like at least today, and that could be verified. But then really all the other ones you kind of don't know. Right. Yeah. And sort of that is kind of the big trust assumption for optimistic rollups, in my opinion, is you're kind of trusting that this validator is around, and the incentives is really not great for validators, right? And then I don't want to like sound like suspicious, but like these number ones, I just know like as an entrepreneur, right? If you'd be building this kind of thing and you're like, fuck, there's no validator, you're just going to be a validator, right? Who knows if that's just like the same guy?
It could be you, exactly, yeah.
Right. And so I don't think this is a good way to do it. Right. I don't think, quite frankly, that like, the government will for a long time think that this is a good way to do it, because like people, kind of double whammy where like, users trust these aggregators with all of their money, and aggregators sort of like, say, oh, this could all be, trustless and verified, and it's really kind of not. So that's not great. I'd rather use Google than that. Yeah. Right, well, that's not, that's kind of the one half of the rollups on Ethereum. And then, so BitVM is a bit of a mix. But sort of in the first instance, BitVM is an optimistic rollup. So you're trusting that a validator is around that wants to run that expensive computation and potentially not make any money. All right. The other ones are sort of really technically advanced. They use a technique called zero knowledge proofs, and that is something from
Zcash.
Right. Yeah, so Zcash uses zero knowledge proofs, for example. Yep. And so what zero knowledge proofs allow you to do is, it's actually kind of cool for a cloud service provider. You could kind of ask them to compute something, and without having to reveal your data to that cloud service provider, right? You have some data, you want some computation to be performed on that, and then the cloud service provider will give you yes or no answers at least, right? And without him learning anything about your inputs. So that's a pretty cool kind of privacy thing. But like they're not used for that privacy aspect actually in Bitcoin, right? Let's just walk through how that works, right? So again, there's an aggregator, but this time the assumption is not that the aggregator is honest. This time the aggregator needs to prove that they're honest every single time, right? So now what they do is they publish this L2 batch and the validity proof, that is, some proof that they didn't lie. Right, that's sort of if you evaluate all these L2 batch transactions, you get exactly the state root as was posted by this aggregator, right? And so in that case, that is kind of cool, because there's no validators required. You don't have to trust that validators are around or anything like that. You're just like, if that proof goes through, that's great, right? The disadvantage is that this validity proof needs to be evaluated on the L1, right? And sort of that is the reason that usually transaction costs for zero knowledge proofs are higher, not much higher, a little bit higher than for optimistic rollups, right? And so all that sounds great, but they come in 2 variants, and that's kind of where problems arise. There's 2 kinds of these zero knowledge proofs. They're Starks and Snarks. So the Starks are completely trustless, right? They don't require any trusted setup, but they're computationally very expensive. Right, so this is hard to sort of break down, but it's kind of really depends on how big your input is. If you're not computing all too much, it's very, very, very expensive. If you're computing like a ton of results, you actually have some savings. But the question if this is practical or not It's really just a question of like, how big is, very small and how big is very big, right? Do these have to be like terabytes for this to be efficient, or how does it work? So there's sort of some problems sort of getting off the boot. And so in practice, these are sort of very expensive to validate. There's a lot of on-chain computation for these guys, but they're completely trustless. So that's cool. And then the snarks is the type of zero-knowledge proofs that Zcash is based on, right? So they're computationally much more efficient, but they sort of just require this trusted setup, right? And sort of, requiring a trusted setup is always kind of a problem. Just think to yourself, I mean, how many of your friends and acquaintances would you trust who might be incentivized to do the wrong thing and have the ability to potentially someday steal a lot of money, right? Versus the ones that are like, you trust that they're so honest that they're just like, no, I would never do this. And nobody would know if they're good guys or the bad guys. So a lot of questions, around this trusted setup. And so my bottom line is that all of these things are very,
trusted.
Complicated.
Yeah. And all of them, we have to extend some variety of trust.
Yeah, and to me, like, trust is really a pretty sort of binary thing. Like, I don't know if there's like, okay, now there's just like 10 unknown guys that I have to trust. To me, that's just as like untrusted as anything. To me, there's just like, trustless or trusted. And if anything is trustless, trusted, we have cloud computing, right? And we have all these great firms, and it works really, really well, right? So the question is always, what is the point of this whole blockchain thing, making things very expensive, very slow, low throughput and everything, if we're not really distinguished in a strong way from the whole world of cloud computing, right? And then, just like in database systems, there's kind of a space for everything like that. I think in the future, there's going to be different kinds of smart contract systems, kind of for different use case. And I'm sort of like on the purist side maybe, or something like that. I'm like, well, I want smart contract systems that are just as trustless as Litecoin, right? That have just this fantastic user experience as on-chain Litecoin. So who has ever used these blockchains on-chain, right? L1, it's an incredible user experience, right? You broadcast your transactions. If you didn't underpay the fee, which is very hard to do on Litecoin because fees are very low.
Yes.
The transaction goes through. You get a zero confirmation message after 2 seconds, which is like insane, just like in the payments world, right? So I pay all salaries in Bitcoin, and I can just send me emails. Here's my invoice, and I can always put I send them the money and I send them the link to the transaction. So there's like no dispute, and like after 2 seconds, I get this. The zero confirmation was incredibly valuable, right? And then in Litecoin specifically, with the new confirmation coming in every 2 minutes, is amazing. And also, by the way, if you compare this with the fiat world of sending money, right? So I live in the States. I'm from Europe, and sometimes I send money back and forth. It takes like weeks, number one, right? And you don't really know what happens. You send it here, it disappears from your balance on the one account. It literally goes into the literal ether, right? For like weeks. And reappear somewhere here, but then even not this, and then you ask this bank, can you see that this money is incoming? And they have no idea. There's like no such concept as zero confirmation. There's not even, they should just like send an email. I don't know why that's so hard, right? Because the receiving bank has no idea which money is incoming. As far as I understand it, I looked into this a little bit. Johnny Litecoin will be able to answer this question, I think.
Yes, he will.
As far as I know, there's no such thing as zero conf, and it's very, very annoying if you pay a lot of transcontinental payments. And like if I paid the salaries in fiat, all of my employees would get their money 2 weeks late. And I get it in bad and stuff like that. And this way, after 2 seconds, they have the assurance, and then usually after 2.5 minutes, they kind of have a confirmation, and they're kind of good to go.
Yeah, and that's why Bitcoin. I'll interrupt just for a moment. That's why Bitcoin, I think, initially took off. Because it is dramatically better than the legacy systems, the fiat systems, the banking system as we know it. Of course, the PayPals and things have changed that, but that's not final settlement. And again, we'll defer to Johnny Litecoin on those things. But I mean, if you compare Bitcoin and Litecoin, though, like Litecoin is so much better. I actually used Bitcoin as money about 2 weeks ago. Wow, unbelievable! And it was a terrible experience. And, I had to RBF, I think 2 or 3 times, judging by the mempool. And then I think within an hour, I got the payment through, but it took a long time. Every single time I send, a payment on Litecoin, or move, Litecoin from here to there. I mean, it's nearly instant. So, it's night and day. So yes, Bitcoin changed the world, but Litecoin versus Bitcoin is also a dramatic improvement. So I'll leave it at that. Go ahead.
Yeah, no, I'm also a huge fan of Litecoin, and just like this thing of having, sufficient block space and just like keeping fees minimal and a fraction of a cent. And because if you have sufficient blockchain, like magical things tend to happen. It is kind of astounding that with all this, IT tech that we've developed, that payments have not become cheaper, right? They're de facto almost always still 3%. And you would think that like if there's progress in the world, why isn't there like a competitor that is like, well, we're gonna do like, credit card for 1% or like payments for whatever.
Yep.
It doesn't exist. But on Litecoin with sufficient block space, what happened over time is that payments get cheaper and cheaper and cheaper and cheaper,
Yep.
right? And there's a lot of people for who like payments is a problem. It's crazy.
Yeah,
well.
Kerry Washington was on a few episodes ago, and he talked about a lot of other countries, not necessarily first world, they're seeing activity in kind of their heat maps, and they're seeing a lot of that happening, or the use of Litecoin in their specific wallet environment in other places. So yeah, we have kind of an advantage, or maybe not even kind of, a pretty significant advantage using the US dollar, to be honest. Yes, it's fiat, but it works pretty good. But other countries do not have that kind of luxury. So yeah, that's a real powerful use use case for Litecoin, and one of the original kind of diffusion methods to kind of get the word out. The old days, let's bank the unbanked, et cetera. I think that's still very valid, and people are using Litecoin for that. So, but of course, it's available to anyone, anywhere in the world. And we're talking from the first world, as we call it, and we're still loving Litecoin for our reasons too. So there's lots of cases for Litecoin.
Yeah, and then just the case for Litecoin in the developing world is just like even stronger, right? Mm-hmm. So I spent some time in Argentina, just like look at the chart of like the Argentinian peso versus Bitcoin, mm-hmm. right? That's like, that just always goes up because like their currency goes down so quickly. Yep. So the worse shape the currency is, obviously, the bigger the quality gap to crypto is, really.
Yep.
Yeah. All right, should we head on with the talk here?
We should. I like our rabbit trails, but yes, let's get to it.
Taking on all the rabbit hole, that's great. All right, so now kind of to summarize a little bit here, it's actually a little bit of a depressing picture, right? So all the smart contract systems for Litecoin I've sort of, explained here are, throwaway, what arguably makes the whole crypto, project worthwhile, which is just like trustlessness, mm-hmm. right? And sort of, I don't want to add on this like sad point, but I think there's a change in perspective sort of required to find the solution. And one way to do this is to just look at what are people actually using blockchains for, right? And specifically Ethereum, right? We can always bridge to all different chains, but where are we actually bridging, right? In reality, we're bridging to like either UTXO Oblaze blockchain or Ethereum, right? UTXO blockchains have very challenged in the smart contract department, right? But we can just see what do people use smart contracts for Ethereum, right? And we can see, you can find different numbers. Okay, so this was actually the slightly depressing overview that I mentioned, that like all these, approaches that are presented so far are just like not trustless, right? But then if you look on what people actually use Ethereum for, you can see that there's 80%, there's different numbers, sometimes it says 75%, I don't know. But the majority of smart contract uses in Ethereum are just like fungible and non-fungible tokens, mm-hmm. right? And so the question is, do we even have to like do all this complicated trusted stuff to bridge to another blockchain when we're just going to do, fungible and non-fungible token? And specifically because it is known that Bitcoin has fantastic support for fungible and non-fungible tokens, right? So recently be reinvented as ordinals and rooms to great success, but they've been on Bitcoin since I haven't looked it up, I think 2012 or something like that, with all the
with Omni. Omni?
Yeah. So all these, I'm sorry, I didn't understand. Yeah. Omni, Counterparty, all these kind of projects have very, very good on-chain, fungible, non-fungible token support, right? And they have fantastic usability, right? Because the only thing you do is you just create a transaction with like a little bit of metadata for that protocol, just broadcast it to the blockchain. You get the same wonderful zero confirmation. You get like all the same confirmation, just like the exact same user experience, just like payments. Right. And sort of when I started working on smart contracts for Bitcoin, actually, I think 6 years ago now, and that was kind of my starting point. I was like, that seems like the simple and the right approach to doing smart contracts, right? But like sort of the disadvantage has always been, the expressiveness in this case, right? So fungible and non-fungible tokens are cool, but we would really like to do all other sorts of programs on blockchains too, right? Games and exchanges and all this kind of stuff. So the usability seemed great with smart contracts on directly L1 on Litecoin, but it was mostly just a question of expressive power, right? And so now this sort of leads to the second part of my talk, where I sort of explained all the L1 protocols like ordinals and runes and stuff like that. But now before we do that, now we get to the bonus content, which is where I want to teach you, Kyle, how to program.
Beautiful.
So I claim that you already know how to program, and let me just like uncover it for you a little bit. All right, so there's these two important just like concepts in computation, and they're called expressions and values, right? And that's the only thing you have to understand. What are expressions, what are values, to get like a very 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 good high level feeling for what programming actually is, right? Okay, let's try and understand what are expressions, what are values. Okay, expression has many different synonyms, right? People call it code or a program, or like all this is very connected to logic, right? In logic they call these things like formulas, for example, right? But there's also arithmetic expressions, 5 divided by 3 is an expression and stuff like that, right? And then we have sort of names for sets of expressions, right? So JavaScript is, for example, the word for all, the set of all the valid JavaScript programs, right? SQL is the word for all the valid SQL statements, right? And then we have first order logic, which is kind of, the word for all the valid first order logic formulas. And there's like many other logics as well. So this list can be, obviously, there's more programming languages and more logics. It could be extended way far. But that is kind of the idea of what an expression is. And then I tried to define this purpose here. We're starting to get philosophical almost. And it's not the perfect definition. I would say the purpose of expressions is to create and update values, right? And then, or another way to put it is to compute new values from old values, right? And that's really, if you do cloud computing, you kind of tell them, insert this row in the database, and they'll insert the row in the database, right? You post a new photo on Facebook, they'll insert a row in the database, and that's it. And all right, so that's expressions. And then sort of the other part are the values, right? And sort of different synonyms for values is just like data or a database, or in logic they call them models. Not so important, but still interesting that there's always this symmetry with logic as well, right? And again, we have sort of names for sets of these individual data values, right? So JSON is a format that's used in JavaScript for expressing all the types that you use in JavaScript. Relational databases are very well known is the things that essentially look like a spreadsheet, right? Where you kind of have this matrix of rows and columns, and you can, each row, all the rows have the data, right? And that's very not so. And right now, the purpose, this gets even more philosophical, right? I mean, what is the purpose of this data? It's just like information, right? You want to store the state of a game, and you want to record facts of the world. It's just like, information, right? And sort of there's this computation revolves all around the interplay of expressions that sort of, create and update these values, and then, the values that they create, right? And sort of what programming languages do is like the programmer creates an expression, and then it runs the evaluator, and every expression gets evaluated to a value. Any questions at this point, or do you want to go to the examples?
No, keep going. This may include inscriptions, is my guess, but that's just a guess.
Yeah. So first we have to get through our excursion of the basic concepts of computation, and then we'll come back to the ordinals and the runes and everything like that.
Here.
Right? It's just, if I set up this language, I kind of want to give a feeling for what expressions and values, what that means, and then I can use these words in the explanation for runes and ordinals to make it clear. All right, so here we have now examples, right? So here you can see, these are SQL statements, and then we'll come to arithmetic expressions too, right? And then, so we'll play this game, and the game will be, I will read to you the expression, right? And then you have to tell me what value this expression evaluates to. And let me just ask you, how much experience do you have in programming SQL so far?
None.
Yeah, very good. My point is supposed to be here that is really, really, really simple. Everything on computing is actually not that hard, right? Okay, so the expression reads, create a table called users, right, with one column first that has, stores strings of length 50, and one column called last, with one column that stores, 50 characters, right? So that is the expression, right? And then we feed this expression into a SQL evaluator, and the evaluator will spit out a value. Right? And now you have to tell me, this first question is actually rather hard. right? But just listen to the expression. Sorry. So, all right, listen to the expression. Create a table called users with one column called first and one column called last. What is the value that is computed from this expression, what do you think?
First and last, my guess based on the parameter there will be 1 to 50, or is it just first and last as the labels?
Exactly. Well, it's a sort of an empty database table, right? You can think of this as a Excel spreadsheet with no data inside it, but you only have the column names pretty much.
Okay. See,
right?
Yeah.
So it creates a table called user. It would have been easier if I put the table name here, so I made it extra hard for you. I apologize. Right? It creates a table called users, that's not shown, and it has two empty columns called first and last. All right, you're not done yet. Let's move on. So the second expression reads, insert into the users table the values Satoshi and N. What is the value that is returned here?
Satoshi and N under the second, under A and B.
Exactly, right? So now we're starting to fill in data into this, before empty database table, right? And so now we have a table with two columns called first and last, and the sort of the data is just one row, and it is called Satoshi N, just like specified in the expression, right? And now, if the expression reads update the users table, set the last column to Nakamoto, where the last column currently is N.
Correct. So we replace N with Nakamoto.
Right. So we grab this, we figure out,
so
okay,
B2
where last is N, right? And we update this row to saying Nakamoto, right? So this is just like an idea to just make it a little bit more concrete what I mean by, expressions are evaluated and then they produce values. And now we'll make it a little bit, because this seems to have been too easy, we'll make it a little bit more complicated.
Oh, you shouldn't do this to me. By the way, I'm with the PhD, and he's putting me to the test, and we're in front of everyone. So it's a terrific feeling.
No, but you did great. I mean, you're answering all the questions correctly without having prior knowledge of SQL, which is super.
Indeed.
Right?
Yep.
Okay, let's make this. This is going to be harder and easier. So the thing is, I actually glossed over a detail here on this example, and now we will make this detail apparent, right? Okay, so now if the expression is 1 plus 2, and we're talking about arithmetic expressions, what is the value that is computed from 1 plus 2?
3.
Very good, very good. And then now if the expression is, and this is where I glossed over a detail, right? If the expression is x plus 4.
And the output is 7. Yeah, we 3.
Yeah, but now you're, actually it's impossible to tell here.
Okay.
Right? So you have to listen to all my caveats. Like if the assumption is that I tell you nothing else other than the expression is x plus 4, and I don't tell you anything about like anything else on the slide, it's just x plus 4. And you'll be like, Clemens, no, what is x?
Fair enough. We always ask, what is x? Yes.
Exactly. Like you don't know. And if I ask you, what is the value of y plus 1?
We always would say, what is y?
What is y?
Yeah.
And then what do you plus y? So this is why this page is a little bit an oversimplification, but we'll fix it right now. So what you actually have to do is, when I ask you the question, what is the value of x plus 4? I also have to give you this information that the variable x
is 3.
Evaluate 3, right? And so if I ask the question, if x is equal to 3, what is the value of x plus 4? Then obviously you have complete certainty in saying that the value is 7. Right? So this is just to get all the concepts that we need to understand smart contracts on Bitcoin. These are all the things that we need. So we need expressions, we need values, and we need these references for sort of undefined variables, right? Where if you get asked the question, what is the value of that? You just couldn't tell. You need more information, right? And this is what they call like an environment, for example, sometimes, or a closure in JavaScript and stuff like that.
Okay.
All right. So now, end of the quiz, you pass with flying colors.
Beautiful.
I award you a PhD in anything.
Well, I appreciate your thoroughness. It's funny. I had a linguistics professor, Burkhard Moore, who actually went to Berkeley too back in the 60s. And I was out in California, and he was a linguist and a wonderful guy. But you and he, I think you're a younger iteration of this guy. I can see the cultural approach to like the systematic approach. I love it. It's great. So carry on.
I mean, linguistics, if you studied linguistics, you're very close to programming, right? So technically speaking, programming can be considered like as a sub-subject of
this is semantics, yeah. Even with you, I'm noticing while you're on the screen, you're actually matching the cap L versus a lower L, and you're actually having them all uniform.
I'm trying with it.
I was seeing you're making these little slight adjustments, which most people probably wouldn't care about, but you're the philosopher. Yeah.
Study linguistics, then we can actually talk about some other expressions, right? For example, like syntax and semantics are expressions.
Yeah.
And so this is exactly what syntax and semantics is.
Yeah, morphology doesn't apply to these conversations.
I'm sorry?
Phonology, I think I meant to say, not morphology. Yeah. Phonology is not so much in a non-spoken, computing languages, but semantics and syntax, absolutely, yes.
Yes. So syntax is what are all the valid arithmetic expressions, right? So this is a valid arithmetic expression. This is not a valid arithmetic expression, right? So that's what computer scientists call syntax. Is this string a valid arithmetic expression or not, right? And then semantics is exactly this question. Given a valid string, in a specific programming language, and you have to know what the programming language does, what value does it evaluate to, right? That is exactly what semantics kind of means. All right, cool. So we got to this. All right, now I told you, and I will stop to quiz you now, I'm sorry. I told you that I glossed over a detail here in these queries, right? So if you look at this statement here in isolation, and you don't know anything about create table or anything like that, this is actually also a case where you can't answer the question, right? It's telling you, okay, insert into the user table a new row called Satoshi and N, right? If you know nothing else, you're going to be like, well, but what is the users table even, right? There's like already tons of rows. That is not the value that it evaluates to, right? And it's kind of almost like a bit more clear here, right? So here you also don't know the users table, right? If this were the users table and you're telling the evaluator to, update users table and set the last to Nakamoto where the last is equal to N, right? If this table were this guy, then this is not the correct result, right? So this is again an example of kind of a free variable. Go to the next slide, and to just kind of show you that here you also have to tell the program there's always these two things, right? There's the expression, there's the definition of the undefined values, and if you have those two things, then you can compute the next value.
No assumptions.
Yep, exactly, right? All right, cool. So this was already my. In my opinion, these are literally all the important concepts of programming if you want to get a high level understanding, right? And then there's obviously like an endless array of different programming languages, right? But they all do the same thing. You have, expressions and they evaluate two values and you need to like define undefined variables and that's it, right? So you can make a JavaScript example work exactly the same way. Okay, so now we're ready. Now that we have this sort of notation or language down, we can talk about my favorite kinds of smart contract systems on Bitcoin called layer 1 smart contract system, right? And these are all these like, recently en vogue ordinals and rules, but also RC20, like you mentioned, Omni, Counterparty, and also like the Bitcoin Computer system that we've built is also like this layer 1 smart contract system. And, the reason I like them is they're just like simple and they work exactly like Litecoin, right? So there's no extra blockchain, there's no trusted third party, no federation, no complicated validator, aggregator, or something. It's just like a user and the blockchain. And what the user does is they build a transaction, they add some metadata, right? And the metadata is going to be the expressions, by the way, right? And just like add an expression to your transaction and send that to the blockchain. That's the whole usability, right? There's no pegs you need to go through or anything else. So you read this here, to use this, you just like add some metadata or add an expression to a transaction to create or update a value, just like, expressions tend to do, like you just learned, right? That's the whole purpose, right? And then if you want to read the data, parse the metadata, or you can actually say evaluate the expression on the blockchain to compute the blockchain data, the smart contract data, for example, like who owns how many tokens, right? Very simple, and sort of goes down to the core of what programming, kind of pretty much is.
You just need applications to realize it or render it or read it.
I'm sorry?
You would just need an application to render the expression or the data, right? Or an indexer. I think it's been referred to as an indexer. Where if you removed all the indexers, the ordinals would all still be there. You just couldn't see any of them, or you couldn't read them successfully.
Yeah. So you'd have to so each of these, exactly what you just explained, each of these protocols has their own indexer, right? And if you want to read the contract state, you have to download, the BRC20 software, right? And then, apply it to the blockchain. And then this indexer will tell you trustlessly who owns how many tokens. Right. And so they come into two kinds, a block order based and UTXO based. And again, we'll dive into each on the next two slides. So the block order based ones, I think the most popular, well, I should, there's probably more too, right? But BRC20 is an example of a block order based layer 1 smart contract system, right? Okay, so let's see what this does is, okay, again, just like all the L1s, we just, users just broadcast transactions with expressions. We'll walk through the example in a second. And then, what this indexer now does is it reads all the transactions in block order, right? And what it does is it creates one big global value, and it computes this value from all these expressions that are in the blockchain, right? And so it'll just like read all these expressions, transaction per transaction, and just start building up this value. Let's make an example to make it more concrete, right? So this big global value that we be computing is here on the right. Can you see my mouse, by the way?
I can do it. Yep, absolutely. Yep.
Right. Okay, so the values we'll put here on the right, and the transactions with the expressions here we'll put on the left, right? And so like I said, we'll go through all the transactions in block order, right? But we'll start the first value is just like the empty value. This is in JavaScript how you write an empty value, these two parentheses here, right? Mm-hmm. Okay, and then we start parsing, read every transaction until we finally find a transaction. Well, so this is what the indexer does, right? So the indexer finally finds a transaction was a metadata expression that's formatted according to the BRC20 protocol, right? And so here in this example, the expression is this string here, right? And so what it means is, okay, this is a deploy operation. So BRC20, I should say, is a format for a fungible token protocol, right? So this expression means we want to deploy a new fungible token. It's called Lite, and it'll have a supply of 1,000, right? So this is the metadata in the transaction, and then the indexer will go ahead and internally compute this value, right? And the value just says, okay, I'm now aware of a new fungible token in this protocol, and it has a max supply of 1,000, right? Okay, and then the next operation is a mint operation. So that's how these things work. So first we sort of declare that this is a new token, and now we actually create, we mint 100 fresh tokens, and we're going to call them Lite, just like here, right? And then sort of in the metadata, we just kind of keep track. We've learned more information about this, Lite token. In addition to knowing that there's like 1,000, units that can ever be mined, we already know that some dude, the guy who broadcast this transaction, already has 100 of these fungible tokens, right? And now this guy, owner A, wants to transfer one fungible token to the owner B, right? So the owner A would broadcast a transaction with this metadata, right? So this is a transfer operation. I'm talking about the Lite token that was deployed here and mint here. And I'm going to be transferring one token to a user called user B, right? And then the indexer goes ahead, finds this metadata and updates its internal value to just kind of reflect that now at this point, owner A has 99 tokens left and owner B, but no, owner B now has one of these tokens. Right, and so that's just how block order-based protocols work. And really, quite frankly, this is also how Ethereum works, right? So in Ethereum, you also just have transactions. They don't have inputs and outputs. There's no complicated stuff even possible. Each transaction just contains metadata. And what the node does is, it reads these transactions with all this metadata. This metadata in the case of Ethereum is like, EVM instructions, right? It'll be, put this here in this register and move this there and divide this by that and da-da-da-da. So it's just like, and so it just reads all the Ethereum transactions one by one. And essentially you can think of it as literally just like compiling one very long program by just concatenating all of these expressions and just like running the whole thing. And at the end, it'll spit up one big global value where you can load up, all the smart contract data that you wanted to.
Interesting point on this. So the BRC20 to Bitcoin is the same as the LTC20 protocol for Litecoin. Luke Wright actually ported that, or activated that, or enabled it. I don't know the language I want to use. He brought it to Litecoin, and I think he did change it to LTC20 versus the RC, because I think that RC is a remnant of kind of like ERC, sort of that convention. But he changed it specifically, something about loop ring. He didn't want a ring. He didn't want the ring involved. Anyway, LTC20 is equivalent to BRC20.
Exactly.
Interestingly enough, he actually, it may have been the first LTC20 token. It actually was called Lite, L-I-T-E, and it's actually tradable on, I know it's on Chicken Market, etc. And I believe it's been minted out a long time ago, but Lite token actually exists on the LTC20 protocol.
Yep, it does. So yeah, so Luke told me about it, and so this was I made these slides before Luke told me that. So I met him at the conference as well. He told me that. So this was not meant as an advertisement.
Yeah, correct. It's a funny sort of irony. I like it.
Funny, yeah. I mean, Luke's a good guy, so probably interesting to look at for sure. All right, okay. But then, sort of zooming back out again, what is with our evaluation here, right? So the advantage is that we get the exact same user experience that we get on Litecoin, right? You just like add some metadata to the transaction, just do it locally on your computer, send it to any of the miners that you like, right? Or just like even to your own node, and it'll take care of it. And you always have complete self-custody over these objects, right? But sort of the disadvantages is that it's not efficient, right? Sort of just by definition of how these guys work, you have to read every single transaction, right? And you're going to be asking yourself, man, I mean, this guy just like, he deployed a token and he minted one and then he transferred it one time. They really have to parse like all these millions of transactions in the blockchain to compute this. I mean, there must be a better way, right? But like, this is how these protocols currently work. And this is, by the way, also the way Ethereum works. If you want to sync a node, there was a big discussion in Ethereum about sharding, right? Can we essentially sync nodes without looking at every single transaction, right? And this, sadly, that seems to be a little bit abandoned. I think there's a lot of opportunity actually for sharding in Ethereum. And quite frankly, the stuff that we've built for the Bitcoin computer, we could turn into like a sharded version of Ethereum as well. So that's how it currently works. And that's also how these BRC20 token works. And then there's other problems here, is that like the whole evaluation kind of totally depends on the block order, right? So that is what has led in the case of Ethereum to this terrible miner extracted value, or whatever they might call it, thing where now the miners get to reorder the transactions in the block, right? And in some cases they have an opportunity to kind of make money there and to front run you and stuff like that. So that's all pretty terrible. And the other thing that's kind of not so great is we talked about how great zero confirmation is, that you kind of get information about like your state update 2 seconds after you've broadcast the transaction. But any smart contract system that relies on the block order, like while the transactions are not included in the block, there's no information available whatsoever in which order they might be included, right? So if you built an app based on a block order based protocol, it will never be free time, right? You click the button and it'll go into like the little spinner waiting kind of thing. And they can only stop, they could only guess. The only way they can show you value is they wait for the next block to be mined, right? Which like, that Litecoin is pretty cool, 2.5 minutes. But like, in some cases it can be much longer. And on Bitcoin's, on average every 10 minutes, but sometimes it can be 50 minutes or an hour, right? Imagine you play a chess game, you make a move, and you can't update like the user interface for like an hour or something. That's like a terrible user experience. So I'm not the first person to say this. And so no offense to the BRC20. Again, like these are all trailblazers, right? So if I say, criticize them, I criticize things that I like, right? And this was also like some very interesting innovation. But this is just an example, right? So like we said, there's other protocols like Omni and Counterparty that have been around for a long time. And to be honest, there's something I want to look up, whether Omni and Counterparty are actually block order based or UTXO based. That I don't know, right? But so in general, these block order based ones are strictly inferior to the UTXO based ones. UTXO based ones are much better, right? So let's look at how they work. Tiny bit more complicated, but this is where we can really kind of make use of our sort of knowledge of what values and expressions are, pretty much, right? So whereas these block order based protocols, they would parse all the expressions in block order and build up one big global value. These UTXO based protocols are much more fine grained, where they sort of, instead of computing one global value, they sort of compute a value for every single output, right? So that's interesting. And let's just look at these examples, right? So we have an example of the Ordinals protocol and of the Runes protocol here, right? So you've heard like the Ordinals protocol assigns an integer to every Satoshi that was ever mined, right? That's the basic idea. And then also what it does is, if you look at an Ordinal Explorer, for every single output, it'll give you a list of ordinal numbers, right? And so it's just a list of numbers. And so numbers can be pretty big, right? Just because so many Satoshis have been created. So if we want to keep track of them, all the numbers will be pretty big. And then the question is, how long is the list of an output? And it's exactly, the list of numbers for an output is exactly as long as there are Satoshis stored in that output, right? So it's a pretty long list, right? And then then there's essentially just the ordinals protocol, just like, defines how do we assign numbers to coin-based transactions, right? And sort of, we'll just start numbering from 1. And, this is supposed to be the coin-based transaction of the first block at, 50 Bitcoin. And so 50 Bitcoin is 5 billion Satoshi, right? So the output of the coin-based transaction of the first block is conceptually in the ordinals protocol labeled by the numbers 1, 2, 3, 4, 5 until 5 billion, right? And sort of these numbers don't have to be included, obviously, as metadata in the blockchain. So there's an important point. The expressions are always the metadata on the blockchain, and these values are just like computed by the indexer, right? So you don't have to pay to literally, store 5 billion numbers in the blockchain, but you do have to, like, your indexer has to, still sort of store these numbers. And you can use like a little bit shortcut notations, just like we show here, but that's pretty much, what it is, right? And then there's a second rule that I don't want to go into it exactly. You take this list of numbers here, 1 through 5 billion, and how you split that number up into sort of the next outputs, right? And so this is a bit of an advanced example here, but I mean, that's just the gist, right? You have kind of all these Satoshis that you're spending to your disposal. Each Satoshi corresponds to a number. And so you just take all the numbers that you're sort of consuming in the transaction and you're sort of reassigning them to the new outputs, right? So in this case, maybe you have an output with 20 Bitcoin, and one with 30 Bitcoin, and you just start from the beginning. Okay, the first 2 billion numbers representing those 20 Bitcoin will be assigned to the first output. And then, just starting from here, from 2 billion plus 1 to 5 billion, you're going to be assigning to the second output, right? And then this is just a little example that shows you here that, like, sometimes this minus notation is very helpful in keeping the indexer more efficient, right? So that the indexer doesn't need to keep track of literally 5 billion numbers, because that would be insane memory consumption. But in some cases, if you look at these ordinal explorers, you'll also be able to see it. In many cases, you don't just have one range. You could have many different ranges, right? And in the worst case, the indexer literally has to store like one integer number for every Satoshi in that output, right? And but still cool, interesting. I think that would have been much easier. Well, there's literally 2 simple ways to define a fungible token protocol, and this is one of them. The other one is efficient. We ended up with this one for some reason. Right. So let's look at these properties before we'll walk through the runes example in a second. Let's look at the properties. Okay. So like all these level 1 protocols, you have complete self-custody, right? You're just broadcasting a transaction, and like these ordinals are stored in an output. So if you own the output, you own that data, right? And it's kind of more efficient. Now, if we're interested, again, the question of efficiency is, can we compute, for example, the value of this output without having to look at every single transaction, right? And sort of here we can see, we can sort of do that, right? The only thing we have to do is we have to always go back through all of the inputs until we reach all coin-based transactions, right? If you just think of a transaction and think of, if you're allowed to visit other transactions just by following the spending relations, right? You can keep doing that, and eventually you'll always end up at a coin-based transaction, right? So you could compute the value of this output, but you don't have to look at all transactions in the blockchain. You just have to look at all transactions that are sort of reachable from here, which is not also, that's better, right? So that checks like the green box for efficiency in our formulation. But in practice, it's still very inefficient, because you have to look at many different transactions to figure out what this ordinal range is. So in practice, while this in theory, clients would be possible, maybe in practice, the ordinal explorer just reads all the transactions from the first to the last and computes these ranges for all of these things. That's just what it is, right? Do you want to go through the runes example, or should I keep it short?
I think you should. Yeah, I think. Speak. Yes.
Right. So a runes example is like the BRC20 protocol, a protocol for fungible tokens, right? And so this is just how it works. If you want to kind of like deploy a rune, I forget the language now. What was it, like etching?
It's etching and minting. Yes, etching and minting. Yep.
Yeah. So etching is the same thing as deploying, and you do is, as always, you broadcast a transaction with like an expression or some metadata on it, right? And according to the runes protocol, if you want to etch a new rune, this is the metadata, right? So specifically, it's like some efficient encoding of this metadata, but this is kind of what the programmer specifies, right? So again, they say there's a new token called light, and here in the terms, it can specify different things. So here you can say you can mint this token 10 times, and on every mint, 100 sort of tokens get created, right? And then, okay, so now we've sort of, etched or deployed our rune, right? If we want to mint it, the only thing we have to do is we broadcast a transaction where the metadata is just like, okay, I'm minting a token, and the question is which one? And the answer is I'm minting the one that is sort of deployed or etched in block 1, 2, 3, and specifically transaction number 4 in this block, right? So now the rune indexer knows, all right, so this guy's minting. You can go here pretty efficiently, right? Just look up block 1, 2, 3, find the 4th transaction, and see, okay, so what are the terms here? The terms can be minted 10 times. It'll internally kind of maintain how many times it's already been minted, and we're assuming that's okay. And so 100 gets allocated, and then sort of the runes indexer will go ahead and associate the output of this transaction with the value. It stores 100 tokens of the 123.4 token pretty much, right? And the owner of these 100 tokens is the owner of this output, right? So that's what all these UTXO-based protocols have in common. The sort of data ownership is always sort of, essentially guarded by the Bitcoin miners, right? Because the Bitcoin miners will prevent anyone from spending that output who doesn't have the private key for that output, right? So holding these runes or these ordinals is just as secure as holding actual Bitcoin, because it's just stored in the same data structure, guaranteed by the same users, the miners, and so that's a big amount, right? Okay, and now let's look at a transfer of runes, right, which are called edicts in the runes protocol. And this is like all these things are sort of slight simplifications, but mostly I hope to convey the idea, right? And so what these edicts now specify is we have these 100 tokens to consume here, and it's just like, how do these get distributed between the first and the second output of this transaction, right? And so specifically this edict says, right, well, I'm consuming, the token called 123.4, right? So it's referring to this input here. And please send one of these tokens into the output number 0, right? And subsequently the runes indexer will compute the value that, this output contains one token of the 123.4 mint or whatever, or deployment etching, whatever, right? And then the second edict specifies that like 99 tokens go to the output number 1. So then the indexer will assign, compute this value for this, right? And the indexer does other things, right? It'll, like, if you're going to try to send 100 tokens to the second output, the indexer will say, well, this is an invalid transaction, right? It's in the blockchain, but it's not valid according to the runes protocol. So I don't know exactly what happens. But probably they're just like not assigning any tokens, and all these tokens would just get burned, I would suppose, right? Yeah, right. So those are UTXO-based protocols. And now let's again look, the advantages are just the same things, self-custody, and actually now much more efficient, right? So now if you want to know this, the value associated with this output, right, you have to go, through the input, but you don't have to go back all the way back to the Coinbase transaction. You only have to go as long as your inputs sort of spend actual runes transactions, right? So in this case, if you wanted to build a transfer rules, well, again, in practice,
it would just go back to the Genesis block. Well, I'll call it a Genesis block, but the block at which time this activated.
Exactly. And you don't have to go all the way back to the Coinbase transaction. So in this specific example, if you wanted to evaluate, you're just interested in the value of this output, maybe because someone's offering it to sale for you or something like that, you really just have to look at these 3 transactions here, right? Which is sort of optimal. And so that's a very good thing.
And runes so activated on Litecoin block 2675600.
I see. Yep. Shout out to Light runes. Yep. So okay, so this is all great, big improvements, but the problem is and quite frankly, this has been the problem for like long time, is that these protocols do not compose. Right? So we have a very simple protocol for non-fungible tokens, very simple protocol for fungible tokens, and then there's this contract on Ethereum called the 404 contract, which is just the simplest possible combination of a fungible and a non-fungible token. Right? It's really just like a non-fungible token with a little piece of data, some string, anything attached to it. Right? And you think if we have these like very simple protocols for fungible and non-fungible token, there should be some way to like combine these two. Right? But it turns they're just like, it's impossible. right? So these like non-fungible tokens that they sit on one Satoshi, right? That Satoshi can just be on one output. And if you wanted to assign the same, NFT to both outputs, sort of, just can't, because like this ordinal will be in this output or this output. So they're entirely incompatible, right? And this is I gave a talk in San Francisco also many years ago at the SF crypto developers, blockchain developers thing, very cool event. And that's where I explained many years ago that is a problem, that they're non-composable and they're not general purpose, right? And then we have to start thinking of making these protocols composable in general purpose, right? Without introducing lots of trusted third parties, right? Let's preserve everything that's fantastic about Litecoin and just see how far we can kind of take this, right? Mm-hmm. So which applications really can we run with a fantastic user experience on Litecoin, right? So, ordinals and runes have a big success, very user-friendly. Can we sort of build something along these lines, but just where we can express all programs, right? And so that brings me to the Bitcoin computer, where obviously I'm biased because I built it, so I'm going to think it's the best thing. But well,
of course it is.
Okay, let me remind you of this little arithmetic expressions example that we looked at before, right? So it's just like you have an expression and it gets evaluated to a value, right? And then sometimes if the expression has a free variable, you kind of have to tell the system, the indexer, what value you're referring to, pretty much, right? And then how do we make the simplest system, and like all programs, all logics, SQL, JavaScript, Java, C++, they all work exactly like this. So how can we make this picture work with Bitcoin transactions, right? And there's a few design choices, but really not so many. Okay, what are we going to do? We're just going to put the expression is going to be metadata, right? We've seen that from all the other protocols, and so we just store this expression 1 + 2 on the transaction, right? And then where do we put the value? And maybe this is where we have a few design choices. But really the sensible thing to do is just put that value, associate that with the output, right? Just like the ordinal rules protocol would do, right? And then the last remaining third thing that we need to do is what do we do with these arrows here, right? And to me, if you look at it, they already look like inputs to a transaction, right? So maybe if we can make kind of this thing a transaction, and we can just say, okay, we already said this is an output, right? If we have an arrow pointing to an output, that looks a lot like an input, right? And that is the whole Bitcoin computer, right? So we make exactly the same picture here, but now we have Bitcoin transaction. Let me explain the visual syntax, right? We have the white box at the top, that's an input. The big enclosing box is a transaction containing some metadata, and the gray lower box is an output, right? So if we wanted to run exactly this computation here, or any other computation, because they all look like this, just with different metadata and with different values computed, we just, tidy things up like this. And that is the only thing, all thing that the Bitcoin computer is. The user broadcasted transactions with, an expression called 1 + 2, right? The indexer will go ahead and evaluate that expression and compute the value 3, right? And then if it gets to an expression here, like x + 4, where we have this problem where we don't know what x is, right? The Bitcoin computer protocol requires that you have to associate one of the inputs with that, undefined variable, right? And then if you want to evaluate this, find this value here, what you do is you first compute all the values of the outputs that are spent, right? And then you associate that x evaluates to 3, right? And then you have all the information you need to evaluate, this expression x + 4, and you know that the value is going to be 7. Right, and then if you have the expression is y + 1 and the input is associated with the y, then you can compute with certainty that the value here is 8. Right, and so this is a very, very simple approach. It works for all programming language, turns literally every single programming language into a smart contract language, and we have all the best advantages of all the best level 1 protocols, right? Because it's UTXO based, it's level 1. Just has all the advantages, right? And it has client-side validation that we mentioned at the beginning. There's a bit more to be said about client-side validation. Let me just show you. Now I'm pretty much done with the slides, so you can sort of wrap these slides up. Mm-hmm. This is the example that we can go through if you want to, but don't have to, of that just to show how that would work for a non-fungible token, right? So maybe the innovation here is that all these other protocols, they develop their own metadata format, right? So this is the runes metadata format, right? So the ordinals metadata format is super easy because there's no expression whatsoever, mm-hmm. right? There's also an expression, it's just not actually an expression. And then these guys, the BRC20 guys, they also have their own metadata format, right? And that is the problem. People shouldn't be inventing their own metadata formats. We have fantastic formats for computing values from expressions, and they're just called programming languages, right? And so that's what the Bitcoin computer essentially does is, it's a meta protocol like this, where the JavaScript is just the metadata format, right? And since JavaScript, this comes back to the very beginning of our conversation when we talked about Turing completeness, right? So since it is known that JavaScript is also Turing complete, meaning that any program that can be built in any programming language can be built in JavaScript. For that reason, you can specify, and since you can sort of evaluate every single JavaScript program, like this on the blockchain, you can run any possible program on the blockchain, right? And sort of the advantages here is that, okay, it has all these great user experience properties, no KYC, complete self-custody. Again, like the data is associated with the outputs, right? So if you have an NFT, non-fungible token with the Bitcoin computer, that token will be stored in an output, right? And the only way to steal it from you is stealing it from you is as hard as stealing your Bitcoin, right? Because the miners guarantee that no one can spend this output unless they have the data. So it's kind of as secure as Bitcoin, and it was regard to data ownership. It's great user experience. It is expressive, like I said, with since JavaScript is Turing complete. It is efficient. So just like in the Runes protocol, remember, like in the Ordinals protocol, I was like, well, that's sort of efficient to our definition, but really not in practice, because it always have to go back to the Coinbase input. And this one was way more efficient because you only have to look at like a minimal number of transactions. The Bitcoin computer works the same way, right? If you mint, if you deploy a token, that's one transaction. Then you mint a token, it's just one transaction, right? And if you're a programmer, if you want to mint something, you want to create a new object, you call a constructor. If you want to update an object, you call a function call. It's very simple. And sort of now the big advantage versus Ethereum is also something that we mentioned in the beginning, is this question of server-side validation versus client-side validation, right? So the way the Bitcoin computer works is, you're interested in the data for this output because maybe someone wants to sell it to you or whatever, right? And you ask your node, okay, give me this transaction, and sort of download all the transactions I need to compute this output, which is a minimal number of transactions, right? But then you evaluate all this code here locally on your machine, right? So the big advantage that like Litecoin and Bitcoin has when it comes to smart contract is exactly this client-side validation, because that is what makes Ethereum so expensive, is that every node needs to evaluate everybody's smart contract function calls, right? Which is a lot of computation involved. So this goes back to literally like the scalability problems on Bitcoin, right? Remember when the Lightning Network was introduced, people said for good reason, it is not scalable, that if one guy wants to buy a coffee, everybody will forever have to validate that transaction, right? So that is not scalable, right? But the thing is, for payments, this is unavoidable, but for smart contracts, it is unavoidable, right? And in the same way, Ethereum, it is not scalable if whenever I make a move in a chess game, if then until the end of time, everybody needs to replay the computation for their chess game move, that is just like not a good approach, right? And so it's very expensive because you have to force all these people to evaluate your code, right? And then in addition to that, it's all evaluated on servers, and that end users don't even have access, right? Whereas the much better architecture is there's some computation where you can't escape this problem of one guy performing the action and everybody else having to verify that code. And that is the case for payments. It's unavoidable to fix the problem. But smart contract data, we don't have to do like that, right? So smart contract data is way more efficient if it's validated on the client side, because then this has the advantage. Imagine this were a program here that would require a supercomputer to evaluate. Mm-hmm. That would just mean I can never figure out, if I don't have a supercomputer, what the value of this token here is. But if this is just a normal non-fungible token, I can use this smart contract here being completely unaffected by some other smart contract, right? So this is what I mentioned before with sort of perfect sharding, as in the sense what the Bitcoin computer gives you is because every user only has to perform the minimal amount of compute, and instead of having to compute every single smart contract invocation, every single function call, you just evaluate all the function calls that you're interested in, right? And so that's a Bitcoin computer, simple, cheap, and and then there's other little advantages that JavaScript is the most popular programming language in the world. So they do these surveys, how many programmers know this language, and JavaScript always comes up on top. And like Solidity is way down, right? So if you're a business and you want to use smart contracts, you probably don't have Solidity developers in-house if you're not a crypto business, right? And so you have to hire these very expensive Solidity developers, and then you also have to onboard them, right? All your local programmers, they kind of know your business, they know what to do and stuff like that. They have to now teach everything to the other guys. Very, very inefficient, right? And also like the ecosystem, the Solidity ecosystem is tiny compared to the JavaScript ecosystem, right? Ecosystem, there's like thousands of research articles about JavaScript. There's books, there's development environments, there's, testing tools and everything like that. It's way bigger. And so the advantage is that you can, programmers can just use all the tools that they're already used to, that they've been using for years. And then as my last point, my point is that like the question is, what is a good smart contract programming language? And my simplistic view is that the best smart contract language is the one that you are most used to. Right? Even if the language is a little bit quirky, but you're familiar with all the quirks, then you're fine, right? And so and then there's other reasons why JavaScript is sort of an advantage. But for example, JavaScript runs your online banking application, right? If there's a bug in your JavaScript evaluator, like everybody, all your bank customers will get wrong balance and stuff like that. So people take very, very good care not introducing bugs into JavaScript. And the other thing is that it's always backwards compatible. Right, so they're evolving JavaScript, but they don't want to break old websites. So they never change JavaScript in a way that it changed the evaluation of an existing program. They just like add a new feature that your old browser wouldn't support. But with a new browser, you could kind of use it. Yeah. So this brings me the final overview slide. Shows all these L2 smart contracts here. It's like a sad state of affair that they all introduce trust and arguably defeating the purpose of blockchain. And then you have all these L1 based ones, and they're all completely trustless, which is wonderful. But technically, all the other ones, other than Bitcoin Computer, have this problem of not being expressive, of only supporting like either fungible or non-fungible token, and then like in the case of Omni and Counterparty, like 20 different programs, right? And so if the Bitcoin Computer is, to the best of my knowledge, the only one that is expressive and also, by the way, efficient, because you only have to replay a minimal number of transactions. Yep. That's the end of my talk. And then, so please check out our website if you're watching. Thank you very much for your attention. If you suffered through this dry talk. But if you want to, you can actually try out applications that are built using the Bitcoin Computer. So you can find all the URLs here, or you can scan this QR code and check out our docs.
And for those who are listening on audio only, it's explore.bitcoincomputer.io. wallet.bitcoincomputer.io, nft.bitcoincomputer.io, and then docs.bitcoincomputer.io. And of course, I will include those in the show notes. But it wasn't dry. I think it's amazing that we got a full-blown lecture. So thank you. We're back on the screen. So no, this is great. I'm thrilled to have you here, like I said, and talk about all these important concepts. And I wanted to ask, actually, is the Bitcoin computer, or in our case, the Litecoin computer, not that Bitcoin and Litecoin are not hand-in-hand friendly, compatible. I think that is the old model, and I think it should continue, although I'm here for Litecoin. Again, when I tried to spend my Bitcoin like money, it was a terrible experience, but Litecoin never gives me that experience. So cheers for Litecoin. But either way, I was curious if this was a concept or if this is actually live. So it looks like you do have the Litecoin computer operating.
Exactly, yeah. So we have sort of the Litecoin computer and the Bitcoin computer both operating. So it's very simple. Since both are UTXO-based blockchains, they're very, very similar for good reasons. It's very easy to port these protocols between one another. So we have it working right now on Bitcoin and Litecoin and Papercoin, I think, because the good guys of Papercoin built an integration. But we want to add support for all the UTXO-based blockchains. I mean, so my favorite ones are also obviously Bitcoin, Litecoin, and Dogecoin, right? And then, but like people are now excited about Bell's coin.
Yeah, and they're aggressive. Those folks, they'll probably hop on real quick. They're implementing the entire like kitchen sink. I mean, everything's going on that chain right now, which is pretty wild.
Yeah, so it'd be very easy to port to Bell's coin if someone's interested. They can literally just look at the PR. I mean, just ask me on Telegram as well. But they can look at the PR for Bitcoin. It'll be exactly the same thing. You plug in some magic numbers, and it'll be very easy to support them all. Yeah.
Very cool. So the Litecoin computer, the Bitcoin computer, these things are already live.
Yeah, and maybe I should add a bit more detail. So I started working on this like 6 years ago. I literally started thinking about it even longer than that. And I started publishing code like very early when it was much more embarrassing than now. Mm-hmm. And And sort of, it was, once you figure out how to build it, it's not hard to build, but it's a little bit hard to figure out how exactly to deal with all the intricacies of like a full Turing complete kind of language. And sort of, I had that idea. Weirdly, the answer came from a paper from the 80s. I'm not going to say which one. And that sort of just clearly set out how exactly we kind of need to build this. And then I found this paper. So it's now August 2024. I found the paper in the spring of 2023, so over a year ago. That kind of cleared up just my mind how exactly to build it. And then it took until like December last year until we had it working for all JavaScript programs. Right? So we have these, randomized tests where you just like generate a random JavaScript program, and you kind of check that the Bitcoin computer evaluates these expressions just like the normal JavaScript evaluator does. So it's kind of pretty easy to test. And we just generate tons of these random programs, and every time we run the test. So they've been passing since last December, and so since December we're pretty obsessed with sort of code quality and refactoring and refining and stuff like that. So we've not added many features at all. We've mostly sort of just worked on making the code easier to read, fix little bugs. We're now sort of slowly starting to work on efficiency. So specifically my co-founder Laura. Okay, well, so recently last thing we had to do is support block reorgs. Block reorgs are always pretty gnarly to support for these protocols, but luckily Laura was able to figure out how we can do that. And now we're working on optimizations. So we talked about before that to compute the value associated with an output, you have to download a bunch of transactions, right? It's the minimal number of transactions, but if you have like a token that's been sent around 10 times, you still have to download 10 transactions. That tends to be slow. So Laura's implementing a caching mechanism where you only have to sync against every output exactly once, and then it'll just be stored on your computer. So that will be like it sounds crazy, but it's true, 1000x performance improvement, just because it takes very long to fetch some data over the internet, versus if you can cache it in your computer, most likely it'll be in main memory, and you can look up that the difference in time between looking into your main memory and doing HTTP requests over the internet is a factor of 1,000. So that'll be great. And then in future updates, we'll work on, so this conceptually kind of makes the second sync faster, right? The first time you still have to download all the 10 transactions, but then you just sort of memorize what they say, the value, and you don't have to download any transactions anymore. You just look it up locally. And the next, Laura, next we'll be working on making the first sync more efficient. I mean, that's other details. And then we'll add sort of server push so that you don't, to actually minimize traffic. And it's very, very cool in my opinion, because we have everything fit so nicely and harmonically together that we can kind of apply these optimizations that usually the application developer would do, right? So traditionally you would build a website, there's no caching, and then you have to add caching on top of that. And if you build a website with a Bitcoin computer now, once we have caching implemented, it'll just automatically cache optimally. So it's very interesting.
How does one access the Litecoin computer? Do we just contact you? How does it work for someone to onboard or start actually using or broadcasting to or operating within this environment?
Yep. So we have a GitHub repo. You can just go to the GitHub repo and download the code. And we have the code on NPM, so it's kind of freely available for free download. And it's like, so the core of the Bitcoin computer is currently obfuscated, because we want to one day it's a whole, if you're interested, I can tell you why it's obfuscated. But the core is obfuscated, but like 95% of the code that we write, and literally almost all the new code that we write right now, is all open source. So these example applications like this wallet that we have is just like a JavaScript React wallet, and the NFT site, we have an NFT site with trustless NFT tradings that can be very easily made to work with ordinals. That's also open source. You can look it up. So you just go to bitcoincomputer.io and you can find all the links. It'll link you to the documentation, and you can find the GitHub and all the links from there.
Got it. And I will ask you to send those to me so I can include them in the show notes. So by the time this is published, by the time you're listening, folks, you can check the show notes and get these links. Are you the only kind of crypto computer environment that is supporting JavaScript?
As far as I know, yeah.
So that's gigantic then.
So there are other blockchains, I suppose, that use JavaScript as a smart contract language, but we're sort of the only one for Bitcoin for sure. Well, yeah, it's easy.
And BitVM is Solidity?
Well, BitVM, I'm not even entirely sure how that will work. I think you will be able to compile all sorts of different languages to have them be evaluated in BitVM.
Okay. BitVM versus Bitcoin Computer. Did you start yours prior? Did they start building this sort of concept? I mean, you're two different entities. You may not even know this, but I'm just curious how you track one versus the other.
Yeah, so I've been doing this for a long time, like 6 years or something like that. And BitVM has been for around, I don't know how much they've been working on it in secret, but I think like this BitVM one paper was launched, I would suppose, less than 2 years ago or something.
I thought so. I thought they were younger. Yep, correct. Yep. Yeah. And EVM too.
Is that BitVM is an optimistic rollup, right? So you're sort of trusting that there is like an eager validator around that will check that the aggregator doesn't lie. That's the downside. They are this gets quite subtle, right? This question of Turing completeness is actually a little bit. It has been designed not for smart contracts, and I think we would actually need a new definition of Turing completeness in the context of smart contracts, right? But so while the Bitcoin computer is Turing complete, because you can run any JavaScript program, there's still weirdly smart contracts that you can't just do nilly-willy like that. And sort of there's one exception that I'm aware of, which are prediction markets where the players aren't known in advance, right? So that's something where we currently don't know if we can do it on the Bitcoin computer or not. So you can do all games where all the players are known in advance, right? So you can get together with 10 friends and bet on the World Cup if you want or something, and that can be run through a smart contract on the Bitcoin computer. But if you wanted to build something like Polymarket, where you don't know who's going to sign up, tomorrow, and they want to be able to throw their same money into the pool. So that is something that we currently don't know how to build on the Bitcoin computer. So this is where I come back to this point where I said before that I think in the future there's just going to be just like they have different database systems now, they'll have different smart contract systems. And so there are smart contracts that are just like not possible on the Bitcoin computer or super awkward on the Bitcoin computer. And I think they should use, BitVM-based smart contracts for those. But the advantage of the Bitcoin computer is there's a much better user experience, right? So they don't, it's trustless. They don't have to hope that the validator is around. And then also, this is something I didn't mention with these optimistic rollups. You have to allow some time for the validator to go through this validation process, right? And that's why they have these lockup periods. And from what I know on Ethereum, these lockup periods are usually a week or two, right? So you play some game on your L2 and you want to cash in your winnings, but you have to wait for 1 or 2 weeks until they actually send the winnings to you. Whereas on the Bitcoin computer, just zero confirmation. You click the withdraw button, you immediately sort of get your money. So there's sort of pros and cons to both approaches.
And what about the Ethereum virtual machine?
Yeah, so there sort of the big difference is that between user validated and miner validated, right? This is the thing that I mentioned before that like, all the miners have to execute all the smart contracts. And so for that reason, the cost model of Ethereum is that you have to pay the miners for every single computational step, right? And then again, arguably, the point of algorithms is to have computations with many computational steps. If we have algorithms with a few computational steps, you use a pen and a piece of paper, right? But on Ethereum, the fact is that all the algorithms with many computational steps are very, very expensive just because the cost is proportional to the number of computational steps. And that's the case for all of the miner validated smart contract system and sort of the Bitcoin computer and ordinals and rules. And they're all sort of, client side validated. So essentially you get computation for free, right? You just like inscribe the JavaScript expression that takes like a gazillion computational steps, but it might just be a very small expression typically, right? And then whoever is interested in this example I made with the supercomputer, if you're interested in evaluating that expression, you throw that on your supercomputer. But if you're not, you just like don't evaluate that, and you're not disturbing anything. So there's a massive opportunity, quite frankly, that like, de facto people are only building smart contracts for Ethereum or similar blockchains right now, and they all have this constraint in mind. If I use a lot of computation, it'll just get way too expensive. Right? Imagine a social network where liking a post is proportional to the number of users of that social network. Right? That doesn't work. Right? It needs to be fixed cost. And so again, just like in the case of Bitcoin versus Bitcoin computer, there's ones that fit better on Bitcoin, others better on Bitcoin computer. In Ethereum is the same thing. And here it's like the ones with a lot of computation will be much cheaper on the Bitcoin computer, and then others on Ethereum. Yeah.
And it would seem like the Bitcoin computer, the Litecoin computer are more expansive, seeing that they're incorporating all of the language that isn't supported otherwise, JavaScript and the other coding languages, correct?
Well, so expansive in the if we sort of interpret that as expressive, there's this weird thing with the Turing completeness, and then in terms of expressive power, they're exactly the same. Any program that you can build in Solidity, you can also build in JavaScript.
Okay.
Caveats aside about like the question of the definition of Turing completeness.
But the language itself, you'd argue, is a stronger language set because of all the vetting. Like you said, the banking systems are already using this code. There's a million eyes on it. It's not going to be buggy, or at least it's less likely to be buggy or whatever, which is a strength.
Yeah, it's much, much better understood. It's like fantastic research. And then, I mean, the reason...
And more people can operate on it and just pick up if they're familiar with that language.
Yeah. And so JavaScript, as opposed to all other programming language, not just Solidity, has this major advantage of like, Rust. There's a team of probably like 30 guys, and they developed the Rust compiler. But for JavaScript...
And that's with ordinals and runes, Rust. Yep.
Yeah. So this is a different programming language. But I'm just saying, in JavaScript, you have the biggest tech companies on the planet competing neck on neck on who can build the best JavaScript evaluator, because how good your browser works depends critically on how fast the JavaScript evaluator is. And so you have Apple with Safari, Google with Chrome, you have Firefox, and they're all the biggest tech companies in the world are all competing, making the best JavaScript evaluator, and we can use it for smart contracts pretty much.
Very good. Curious, I'll ask the question, the Bitcoin computer, the Litecoin computer, are they incorporating things like runes, ordinals, omnis, zk, the rollups, et cetera? They can incorporate those, or they're separate, as those would be their own virtual machines, if you will. Pardon my language.
Yeah, fantastic question.
Because the ordinals are standalone, right? I can go etch them, or I can go inscribe an ordinal, or I can etch a rune in and of itself in isolation without the Bitcoin or the Litecoin computers. So does your system incorporate those too?
Yeah. So the answer is yes. So we jumped through some hoops to make sure that like the Bitcoin computer is compatible with all existing protocols, and most likely also all the ones that are in the future. So can we just flesh that out just a little bit? So what we did is we built this NFT trading site, right? Where the NFTs are ordinals, right? So anyone can sort of upload their existing ordinal NFT into our site. But what the ordinals protocol doesn't support is trading, right? But the Bitcoin computer does support trading. And so what you can do is you can just make them very nicely compatible, because you have a lot of control with the Bitcoin computer. You can trade them in a way that they sort of respects the runes protocol, right? And then if I buy, the ordinals protocol. So if I buy an ordinal NFT from you, then after the trade, I will have, you will have the money, and I will have, the NFT, and it'll be unencumbered. So they can be made compatible, and we've made a big effort to make them compatible. And I think now they're compatible with ordinals and runes, and I think with many protocols that would come up. Well, I should say with all the ones that are UTXO based. We're currently not compatible with BRC20. Might be in the future. We'll have to see.
Good deal. I'm going to look at the clock. I love that we're going an hour and 53 minutes, by the way. But it's late for both of us. I would like to focus on maybe 5 more questions that I had as a Q&A. Of course, I'll give you an opportunity to close with whatever you want. But does that sound good to you?
That's super, yeah.
Okay, very good. So let's see. Question 1. So, and some of this might be redundant based upon, because these were written in advance, but I think they're still appropriate. And I think they're very basic, again, for somebody that's not coming in despite your lecture, despite learning something over the last hour and 54 minutes. But we'll proceed here. What's your TLDR case for why the world would benefit from Litecoin Computer versus all the other computer operating systems and environments that currently exist? In other words, are we just reinventing the wheel here, or, why do we need to migrate here?
Yep. So I think there's two classes of protocols to compare with the Bitcoin computer. Obviously Ethereum and the other L2s, right? And sort of the big differentiation. The other L2s on Bitcoin, like rollups and sidechains and stuff like that. And the difference between the Bitcoin computer and the existing Bitcoin L2s is that the Bitcoin computer is completely trustless and has exactly the same user experience as on-chain, Litecoin. And the difference with Solidity is this thing about the computational cost, right? So Ethereum is very expensive if you want to run any sort of meaningful computation on Ethereum, right? And that is the reason, by the way, why Web3 apps are so different from Web2 apps. Right? Web2 apps solve actual problems in your life. Uber, you want to go from here to there, I don't have a private driver, you can get it through this app. Why has no one built Uber on Ethereum? The reason is because it's too expensive, right? Uber requires some computation to compute the price, and that will be very expensive on Ethereum. And so here the differentiation is that, like, the Bitcoin Computer essentially sort of enables, a lot of smart contracts at a fixed cost that would literally cost the entire world all the money in the world on Ethereum, right? So it's just like different smart contracts, again, that can be run on the Bitcoin Computer. There's ones that can be run on Bitcoin Computer that would just be very expensive on Ethereum.
Hear, hear. What are the current limits of the Litecoin Computer? Can the world operate within this system environment successfully?
Yeah, so the limits of the Litecoin Computer. So number one, there are certain applications where other smart contract systems are just like better, right? So number one, obviously the ones that we just don't know how to build. Like if you want to build a prediction market like Polymarket, right? I recommend you try. It'll be tough. I don't know. Well, eventually something like this could totally be built on BitVM whenever they're ready. But then currently, obviously, like the Ethereum, ecosystem, or like Polygon or something, some L2 for Ethereum is kind of better. And I guess the other disadvantage is that obviously Ethereum is a huge community, right? And then BitVM is also a big community, and we have not made any marketing efforts so far whatsoever. We're actually trying to change that. We have two fantastic new advisors that we met at the Litecoin conference. Mm-hmm. So we're trying to become better at getting the word out, but it's a very small community right now.
Okay, very good. We're interested to see where this goes. Personally, I'm very interested to see where this goes. You're much more of a. I'm curious of what's in your mind when you look at these things and how you've rolled this out over the past few years, like what your vision is, because I don't think we probably can see perhaps what you can see happening with this and how the world will change because of it. Because we're so used to operating in our current operating systems, which is not this. But if we're all operating on a trustless, we have our own, and we're going to get to that in a minute. We have custody of our own assets on chain. Like, it's just very different than what we're used to now. I'm curious to see where it goes.
Yeah, I mean, so the reason I'm working on this for such a long time is because I think there is this whole world of potential for smart contracts that is just impossible to build on Ethereum, right? Because of this restriction to only using smart contracts that do very few computational steps. Because we use algorithms all day, every day with computers, and all of them use a ton of computational steps. And like every year, we have Moore's law. Every year we can do more computational steps. And so the world of smart contracts on Ethereum is sort of like detached from literally all engineering algorithms and computer science. And I think it would be fantastic. And if we could build all these other applications as smart contracts, right? So for example, I think it would be fantastic if there were an Uber. Uber takes like 50% sometimes, I think, of your ride. Your ride would be 50% cheaper if they could build it smart contract based, right? But like I said, if you were to build it on Ethereum, it would not be 50% cheaper. It would be like a gazillion times higher because the algorithm takes so many steps to compute the price that it wouldn't work. But everybody would be happy if that would be built on blockchain. And then, so there's lots of opportunity. And then especially in the enterprise space, to be honest, there's a lot of opportunity for blockchain that doesn't work on Ethereum because it will be too expensive, and it could work on Litecoin with client-side validation. Yeah.
Ethereum aside, Litecoin aside, Bitcoin aside, these kind of blockchain-based computers. I mean, do you see these eclipsing? For example, I'm on Windows, you're on in the Apple environment. Do you see these totally overtaking them? Or do you see those environments just incorporating them? Or will there always just be two worlds of where you want to run your program, whether it's a traditional old school legacy, computer that you buy at your Best Buy or whatever, versus you're operating within, Bitcoin or Litecoin? How do you see that? I mean, do you see the future being like these old systems are going away, or they'll coexist forever until one totally eclipses the other? Or what does that look like to you? I'm curious. The world is not thinking like you. The world thinks of their phone. They think of their laptop. They think of going to their cafe and going on Wi-Fi. Like, it's not, oh, I need to go and compute on Bitcoin. But I think that's where we're going. And you're one of the first to do it.
Yeah, so it's sort of the question of what is the overhead of a smart contract, right? So if you have the choice of running something just like as a normal program in the cloud computing environment, for example, or something like that, versus running as a smart contract. I mean, a smart contract is technically, I mean, it's more expensive, but other than that, it's much better, right? So it's really just a question of this cost.
Well, you mentioned running Uber on a Litecoin computer.
Yeah.
I mean, that's a normal app that everybody uses, right?
Yeah, I think that'll be much better. And the cost would be, you broadcast a transaction to say, I'm here, I want to go there. Everybody can see that, all the drivers can see that transaction. They broadcast a second transaction saying, I'm going to come and pick you up, right? So that's 2 on-chain transactions, and then there's a third for the payment, right? And then Litecoin, like median fees are like a tiny fraction of a cent, a tenth of a cent or something like that. So that'll be much better. And so to answer your question, I think in the foreseeable future, like 100 years, it'll be my operating system example where there's, going to be different, systems for different use cases. If we're not idiots and we can manage to make the cost of an on-chain transaction go down, right? Eventually it'll be like minimal overhead to just like, broadcast one transaction for every function call. And then I could imagine that we're going to be using smart contracts for many, like a lot of computations, right? Because it just literally back up what happened on the blockchain. And for any sort of dispute resolution, it's always fantastic to know, what happened, who did it, when did it happen, right? That just makes every single application better, right? So I think maybe one day, if we think in 1,000 years, maybe a lot of things will be smart contracts. But in the foreseeable future, there'll always be, these two different things.
Two different worlds for now. And at the point where we are using, or let's say we get to the point where Uber is running on-chain Litecoin, or my, other version of Uber is on-chain Bitcoin. The graphic user interface is going to be wonderful where you're not even going to know it's Bitcoin or Litecoin. That's going to have to be the fact, because nobody's going to want to, deal with raw code. I mean, again, this is early days, but I think we still think of it in that, and I'm not visualizing where it would go. I think if there's an Uber or some sort of ride sharing on these chains, it's going to look like anything else on your phone, but it's just the back end is Bitcoin, and that's crazy. And I would, yes, agree that currently Bitcoin absolutely could not handle that.
Yeah, so I mean, just like in the case of Bitcoin, if we're talking about 3 on-chain transactions, right? I mean, realistically, like, I make payments for these Bitcoin payments for these salaries, and mostly I pay like $1. But even if it's $1, it's like annoying if there's like $3 extra for you. I mean, Uber might just be $7, and then $3 in fees. So it's like a little bit stupid. But then other days, like fees are $10, right? And then if 3 on-chain transactions are like at $30 to your local price, it's the same reason. No one will use it. It's just too expensive. If you want to compete with the legacy system in the United States, functions fantastically, right? There's like minor issues with zero confirmation, stuff like that. Mostly works really, really well. The only way you could compete as a crypto is compete on price. Litecoin can do that. Litecoin is way cheaper, way faster than the legacy system. Bitcoin's also faster, but sadly not cheaper.
And between using the Litecoin computer versus the Bitcoin computer, what would be your rationale to use one over the other?
Yeah, like in almost all cases, Litecoin. I'm a huge fan of Litecoin. I think it's awesome. And there's no reason that Bitcoin could be just as cheap as Litecoin. There's no good reason. And
so what happened?
Well, they kept the block size small. And yeah. So this is it's interesting that you bring that up, because I thought for a long time whether you would bring this up and whether I should answer and speak my truth.
I wasn't planning on bringing this up. It just felt appropriate.
And like this blockchain debate, there's this fable of the emperor's new clothes. Have you heard of that? Maybe that's a German thing. I don't know.
No, I know the story. Yeah, the emperor's new clothes. Yeah, absolutely. Yep.
So it's a story of like the emperor has like some new fashion designer, and the fashion designer is like, this fantastic new fabric, and only idiots can't see it. Right? And the king can't see it, but he doesn't want to admit he's an idiot, so he doesn't say anything. And then he goes parade around in front of his people, and nobody wants to admit that they can't see it, right? Because nobody wants to seem like an idiot, right? But then one kid blurts out, "He's naked."
The emperor has no clothes. Yep.
All of a sudden sees it, and literally the same thing is true with the block size, right? So everybody who studied computer science must know that it is stupid. And if you haven't studied computer science, you must also think to yourself, I mean, try to use like your iPhone from 2009, right? And try to run any applications on that today. And the idea that like we should have like no advancements in throughput or price or anything in years. And that is always supposed to stay like this in the world where everything grows exponentially is absurd. You don't have to be a computer scientist, just like your intuition tells you that. And like, that's what I'm saying, like these 10,000 views from 10,000 feet are very, very helpful. If something doesn't make sense from 10,000 feet, it typically just doesn't make sense. You don't have to be an expert, right? Okay, but then let me actually analyze this a little bit because it's very sort of kind of interesting. And so first thing people need to understand is the relationship between the block size and the size of the blockchain, right? And it's very simple. The size of the blockchain after so many blocks is just like the sum of all of the individual block sizes.
And it would be infinite.
Yeah, eventually it will be infinite, but at every point in time, it started, whatever, in 2009, currently it has some size and it grows linearly. Since we have a constant block size, the increase is always the same. And then they had these bips, back in the day, Andreessen, who proposed to double the block size every 4 years, right? Which would mean, and then you have to remind yourselves of integration and differentiation and stuff like that. So the thing that makes the exponential function special is that if you integrate it or derivative, the integral and the derivative of an exponential function is an exponential. So if you increase the block size exponentially over time, the size of the entire blockchain also grows exponentially over time. Right? So that is something that you really have to wrap your head around because the block size is constant, blockchain grows linearly, the block size grows exponentially, the blockchain size grows exponentially, and there's many things in the middle as well. Okay, now what does this have to do with like nodes and miners and everything like that? So you have to like just always simplify things. What should, in my opinion, the goal of keeping, it's very important to keep Bitcoin decentralized, no question about that whatsoever. Again, that is the point of Bitcoin, to make it decentralized and to allow as many people as possible to run their nodes. But let's sort of zoom out a little bit and take a longer time horizon. What do we want about the cost of a Bitcoin node? And I'm just going to say, simplifying, we want that to stay constant. Right? So running a Bitcoin node right now is actually super cheap. If you buy your own hardware, you buy yourself like $1,000 or $2,000, or probably like like some cheap piece of hardware, and then electricity is next to nothing, right? So I think that's an okay price right now. Everybody can validate the blockchain if they really want to. So let's just say we want to keep the price of validating the blockchain constant, okay? And then what is the relationship between the cost of validation and the size of the blockchain? Is directly proportional, right? So it's just like the cost of maintaining the node is just proportional sort of to the block size. But then you have to take into account that over time, computers get more powerful, right? This is this intuition that I mentioned in the beginning. And we have data going back, very good data going back 50 years, and we have less good data that goes back 100 years, that technological progress in every single way is exponential, right? There's many examples. There's like, the cost per compute, sort of the amount of compute you can do at a fixed cost increases exponentially. For example, the amount of data you can send over the network at a fixed cost increases exponentially. The cost of your hard drive, how much hard drive you can buy per dollar increases exponentially. They're all slightly different rates, right? Moore's law, it kind of doubles every 2 years, and then internet throughput is a little slower, I think Nielsen's law, but they all grow exponentially and they have forever, right? So now if we put all these different pieces together, in the wonderful BIP 100 and BIP 101 world, where the block size gets doubled every 2 years, we have the blockchain size grow exponentially over time, right? We have the cost of compute sort of going down exponentially over time. So the cost of running a node stays constant until the end of time if we just increase the block size exponentially. Right? And sort of currently in this world that we're living is okay, we're increasing the block size linearly, so really it's going to get cheaper every year to run a node. But there's really not a lot of point in that. You can now run a node on, like, I think the second smallest machine on AWS. So there's no point in kind of making it any cheaper. And so I think it just like all aligns. if you increase the block size exponentially. And then, okay, now let's get into this argument that's usually made, Moore's law is dead, right? When people say Moore's law is dead, they don't really mean that this function of technological progress that has been exponential for like 50 years is now going to turn into a linear function, because that is like a discontinuous function that just doesn't look natural. What they're talking about when they're saying, Moore's law dies, they're saying, okay, maybe it'll not, the compute won't like double every 2 years, maybe it'll be every 4 years or something like that, right? And that's why, by the way, bit 100 or 101, I don't know, they want to double it not every 2 years, but every 4 years. They were sort of conservative, and they were like, we're going to do this for like so many years, I think 20 years, and then we'll reconsider it and stuff like that. So okay, let me come to my conclusion now. If you're adamantly of the opinion that the block size must always be constant, really what you're saying is Moore's law is coming to an end. It's coming to an end right now, and it's going from an exponential function to a linear function, right? And then the difference between an exponential function and a linear function cannot be overstated, right? So if you zoomed out, so imagine this chart, we have an exponential function going here, and then it goes linear. If you zoom out of this chart, what happens is that this exponential function literally goes vertical, and your linear function literally goes horizontal, because you have to compress the y-axis to fit all your exponential data. So if you're adamantly convinced that the blockchain must be constant, we can't even increase it linearly, right? Which would give us quadratic. We're constant. Then you're saying technology progress has been vertical until here. It's going to be no progress going from here forwards, and you are exactly here. That, my friends, is hard to believe, right? And that is not. It doesn't require advanced mathematics. That's just like user intuition. Look at your mobile phone. Analyze things. There's nothing's complicated. The blockchain size is the sum of the blocks. You have compute that goes up over time. And what we could have, and that is, by the way, what Satoshi claimed, is that supply would always outstrip demand, right? So what this means is that how is demand for block data increasing, right? So it's hard to say, but you can look at a proxy, for example, in payments, and you can just like whip out your latest market analysis for the payments industry, like booming industry, and they're growing, last I checked, I think at 14% per year, right? According to Moore's law, if it were to double every 2 years, we could increase the block size while keeping the cost of running a node constant by 40% a year, right? So what happens now? This is just economics. What happens in a market where supply always outstrips demands? Costs are minimal, right? So the costs for the miners, they're just like, okay, validating this transaction costs nothing for me, compared to how do miners work? They have like a huge server farm for mining, and then a laptop to validate the transactions. They're like, yeah, that doesn't cost anything. I really don't care. And so what they just do is they include every transaction if block size is sufficient at like just the minimum profit margin. It just needs to be enough to convince that miner to not go look for a different job, which is very little if you can pay. And so the world that we can live in is literally, the miners could have this Coca-Cola model. And this is something, quite frankly, if there's any miner listening, that miners really need to wrap their head around, right? What is the long-term perspective for the mining market in the small world versus a big block world, right? So in the small block world, currently they have very high fees, so they have a lot of income, but they're not increasing their supply. Yeah. And people, it's to a certain extent an inelastic good. People will not start paying thousands of dollars per transaction, or just like not at the volume that they need. So literally, if miners think really long term, at a fixed block size, they're sitting at a constant market, right? It'll just like not go up. Versus in the big block version, what they're going to do is the Coca-Cola model.
They'd have so many transactions, it would be ridiculous. And even though it's very negligible in terms of fee, they're going to be breaking it down.
And to be precise, they would have an exponentially increasing amount of transactions over time. So they will be looking at an exponentially increasing market size.
So miners should want these old proposals to maybe come to fruition for their own incentives. Yeah.
If miners didn't like big blocks, then miners would have killed Bitcoin Cash a long time ago. They could kill Bitcoin Cash anytime, and I kind of think that literally all of them seem to think, well, let's just see what happens. Let's not destroy this. And then there's my last point about this. There's this whole debate about the waning block reward, right? How that halves every years, right? And again, if you're looking at a constant number of transactions, you just like the only way to compensate for this waning block reward is to make each transaction much, much more expensive. And there's only so far that you can go with this, right? If you have an exponentially increasing mining market that makes exponentially more revenue and profit over time, it doesn't, the block reward won't even matter, right? So again, in computer science, the one thing you're taught is to always think super long term. Super long term, there will be no block reward. So we might as well just think there's no block reward, right? Miners should ignore the whole block reward out of their calculation. And they have the choice of big blocks and an exponentially increasing market, which is like a massive boom industry that, the mining industry has a lot of fantastic, advantages and the green movement and all these kind of things. The mining industry could look into an exponential future, and it's currently staring down a stagnant market and a waning security, and they'll kill themselves. And not they won't kill themselves, they just kill the industry.
Yeah, right.
And we're all killing ourselves, and we all hold crypto, and all of our crypto holdings would go way up in value if we increase this block size, and in Bitcoin and Ethereum everywhere, right? But for some reason, everyone seems to be afraid to say that. And that's why I come back to the story of the emperors and emperors. I think everybody in computer science knows this, right? We have like MIT professors, in Bitcoin and Stanford and whatnot, right? I want to hear these guys' opinion on the blockchain. Like no self-respecting computer scientist can make any sort of argument to keep the block size constant, right? I mean, why don't we at least increase it linearly or something like that?
So who's influencing it to be small forever? I mean, of course, Roger Ver wrote Hijacking Bitcoin and things like this. And there was the block size war, and there's different opinions on why that came about. And it's interesting. It's probably short-lived. Necessity might demand us to adopt some of these other proposals, or perhaps Litecoin could just in the future do the BIP 100 101, for our own purposes, and just eclipse Bitcoin entirely. Maybe we should consider these older proposals.
Yeah. So I mean, that's why I'm actually not overly concerned about the block size, quite frankly, because there's always if there's always this argument, okay, Litecoin's so cheap now. What if there's
the thing is, if there's much more demand, it's not going to be as cheap, right?
Yeah, but there's always going to be then someone imagine now Bitcoin, Litecoin, Dogecoin, Bells Coin, all of them, they all charge $100 per transaction. Well, I will start a new blockchain and it'll be tens of percent. There will always be free block space on a UTXO-based blockchain, right? So that's why I'm not overly concerned about it. And that's also, quite frankly, why I'm building the Bitcoin computer to be compatible with all of them, right? Because someone's not going to be an idiot, right? Yeah. They're going to do it. It's just like every chain that doesn't do it is long-term committing suicide. And I just want to hear a long-term reasoning, or just literally any reasoning. Try to find an article on Google Scholar or anywhere that argues why the block size needs to be constant. There isn't one.
Well, Bitcoin is, especially being alone, it's not merged mined. At least with the 84 million cap of Litecoin. And I like the idea of limited supply. I think that was a big case, and it's still a big case. Although I don't think Satoshi mentioned 21 million in his white paper. But either way, I do like the finite supply. I think that's important. Of course, there's the divisibility to the eighth decimal place, et cetera. Provided you can, send a single Litoshi for I don't know, what would the price be to send a single Litoshi? I guess 1 for 1. You can't go any smaller than that. But anyway, we're not even close to that. But I understand there's divisibility with the finite count of whole units. But even after the 2148 or something like this, the estimated time when the last portion of Litecoin is mined, we will have Doge, and now we'll have Bells. Doge is the most unlimited, rule-based, but the most unlimited. Bells is less unlimited, but still emissions forever. So that's good for miners, script miners. I think there's a lot of good things for script mining. But Bitcoin's king with number go up, but they're also alone. And when they attack other protocols, they're attacking themselves. That's why I don't understand why people, and I think the smart ones won't. They'll omit, but they won't attack, and like even an advocate for legislative action, like, Dennis Porter or something like the Satoshi Action, things like this. He does say that, what he defends for Bitcoin is defending all blockchain, or I would say proof of work. I think the special component is proof of work, at least for money, not saying for other use cases, but for money. I think proof of work is extremely important. So yeah, I think if there are strong personalities in the Bitcoin community that are isolating or attacking, for example, Litecoin, that's a very bad idea, because you're attacking your own protocol.
Yeah.
Yeah.
I mean, Litecoin is literally identical to Bitcoin, just like not stupid in the point where the only thing where the Bitcoin protocol is really stupid, Litecoin isn't. Right. And other than that, they're literally entirely, indistinguishable.
Well, speaking of the emperor has no clothes, I think a lot of that narrative or the parable or whatever this tale is that we tell ourselves, we know about the emperor has no clothes, that has to do with social pressure and kind of a propaganda too, that none of the adults in the room could say it, but the child could say it because of these pressure systems that have been built up. And my concern is, and this is not about, dumping on Bitcoin, but maybe dumping on Bitcoin is good, because maybe it'll make Bitcoin think again, but this idea that they're onboarding, I get it. Whales are fine for all time. They've got a lot of Bitcoin. Doesn't matter to them. But the new folks that are coming in and putting their savings in this sort of vehicle and all these things. And I think there is a case. Yes, digital gold. I'm not against that concept. I think Litecoin's digital silver. But again, gold was hoarded historically, if we're going to use that analogy, and silver was spent. They had different use cases even in the metallic world. But, for you to get your bits and pieces of Bitcoin, and while I think that's a good idea, I do, get your bits and pieces of Bitcoin. I'm not arguing with that. But unfortunately, there's such a strong mental, it seems like the propaganda, the narrative, it's very strong. And I don't think it's serving the people with fractions of a fraction of a Bitcoin, because as fees rise, unless they change some of these things with these protocols, with these, the improvement plans, not protocols, the Bitcoin improvement plans, unless it's significantly changed, I don't see fees going down, at least not on chain. So I just think these people that are going along with this new propaganda of maximalism, they're not even being served by it. They'd be much better off getting Litecoin or Dogecoin or whatever that they can get in full units. They can transact extremely cheaply and use it as money. But anyway, we digress.
But that is the beautiful thing about competition,
right?
So it is sad because Bitcoin is something very special, very unique. That is the reason.
And I agree with that too. Litecoin's here because Bitcoin's here.
Yeah, It's terrible that they destroyed it, right? And this is literally divide and conquer, right? It's like, we'll keep this one shit, so now we have thousands of altcoins, and each of them is kind of not so secure, because it's like the combined security that really gives you kind of the security. Mm-hmm. But at the end of the day, the UTX own model is out there now, and it's amazing, and any child can make it scale. Right. So I was literally told by someone who runs a BSV. I have a lot of issues with the BSV community, right? But someone told me that a very respectable person, I'm sure it's true, that they bought an old laptop for $2,000, and they're running a BSV node on it, and there's millions of transactions per day, and it's like the BSV guys didn't have access to the smartest developers at Silicon Valley. They all weirdly work on the Lightning Network, right? So I'm saying it is stupidly simple to make this scale. And we have an entire, again, decades of research on that, right? So what is dealing with big blocks? There is an entire field. This is where I did my PhD. It is called big data, right? And these are all the algorithms that were, developed at Google and Facebook and tons of, academic grants and stuff like that. We are very, very, very good at dealing with big data, and we know exactly how to do it. And the trick is just to parallelize stuff. And there's a lot of very low-hanging fruit research and how to make nodes more efficient by, for example, just like pruning parallel. You don't have to do it sequentially. There's a lot of simple things that could be done. And the truth is a persistent beast, right? So you can propaganda and lies cost money, and the truth is for free. And people just need to speak the truth, and it'll get out there. So
that's a good statement. Good statement. I have two more questions. We'll end with those, but I've been enjoying these conversations here. So yes, this is about kind of privacy and ownership. How does the Litecoin computer secure or accommodate individual ownership of data? If this is a universal machine on Litecoin, in other words, everyone is using it in the same environment, namely the Litecoin blockchain. what prevents me from accessing and controlling your sensitive data, or even keeping that data sensitive to begin with versus transparent, and vice versa?
Yeah, so data ownership is handled just like in the ordinals or in the runes protocol, where your data that you own, is conceptually stored in an output. And just like if you have Satoshi stored in an output, the owner is the only guy who can send these Satoshi somewhere else. In the case of data, it's, the owner is the only guy who can update this data. And it is the same security mechanism. Sort of the miners essentially enforce the data ownership on the Bitcoin computer, just like on runes or on Bitcoin itself. And sort of privacy is also an important point. Is many applications, obviously blockchain data is completely public, right? It needs to be that way. It doesn't work otherwise. And obviously in applications, you don't want to, number one, put all of the data out there in public. And number two, there's also just like laws and regulations, like GDPR and California consumer protection laws that actually force you to hide things and not make them available to the public. And for that use case, so we've been working on the Bitcoin computer, kind of got funding from lots, not lots, sadly, but a few very large institutions, including, America's biggest banks. And they had essentially written the specs. So we presented the Bitcoin computer to them, and then they were like, well, what you need to have here is encryption, because we need to comply with a GDPR and CCPA. And the other thing was off-chain storage, because certain data, specifically, personal information must never be stored on a blockchain, even if it's encrypted, because users have the right to have their personal data removed. You can send an email to Google and then tell them remove all my data. And if it's stored on a blockchain, even encrypted, should the encryption key ever leak, no one can delete that data. And so you need those two things to be able to comply with the law. And kind of what made this, it was lucky happenstance, I want to say, but also maybe a little bit intentional. But the way that encryption works on the Bitcoin computer is that like all smart contract data is encrypted, with sort of best-in-class AES and those style of encryption algorithms, but the flow of funds is entirely unobfuscated. And that is actually something that's sort of important to us, because the last thing we want to do is build tools that can help money laundering. I don't want to have anything to do with that. I don't want to help criminals or anything like that. And so this is actually a very nice balance where we get all the smart contract data encrypted, so we can, give privacy to the users, but flows of money are still unobfuscated, so that anti-money laundering efforts are not hindered in any way.
Understood. What is our experience like now with the Litecoin computer, the Bitcoin computer? I'll use a Windows reference. Are we at Windows 1.0, 3.1, Windows 95? Where are we at?
Oh my God, that's so hard to say. Number one, because
not literally, but meaning, are we in Stone Age? I mean, this is a young industry.
Okay,
you're a pioneer.
So we'll make the metaphor. I'll try to pick one in a second. I'm going to say that, like, traditionally the Bitcoin computer has been hard to use, and there was years where I was the only one who I think could use it, and we're working very hard to make it easier to use. I think eventually it can be very easy to use, and it'll be much easier to use than Ethereum, just because everybody already knows JavaScript, and you have all these integrations and stuff like that. And so I think right now it's somewhere in the middle. People kind of need to rethink. And now in this Windows analogy, it's very hard to say. So I would say we're beyond MS-DOS. MS-DOS, you needed to be a programmer, and you needed like type in things. That was hard. And I think maybe 3.1 was the first one, was the visual UI.
I believe so. That's where I introduced my, that's where I was introduced to Paint, I believe.
Yeah. That sounds right. Yeah. So maybe we're like 3.1. Well,
okay.
Yeah. So maybe
I have fond memories of 3.1.
Yeah. So maybe that's a pretty good analogy, because in a sense, 3.1 was, very abstractly speaking, sort of feature complete, right? You have icons until today, and you can click on them, but it's just like all the apps got way better, but way far like that. And sort of we have now kind of the API of the Bitcoin computer will actually not radically change in the future, but it will become much more just like much faster, cheaper, and much better documented. So I'm going to go with 3.1.
Okay, very good. And I'm going to scratch the last question because we already asked it. So we're going to land the plane here. It's been great. We had a full-blown lecture. We got a great Q&A, just kind of a rabbit trailing chat. I've enjoyed this very much. But before I close it, do you have any kind of thing you want to add before we end the show?
Well, I mean, I would just sort of like to extend the invitation to the viewers to just check out bitcoincomputer.io, and there's links to our Telegram group, and like, you know, read the documentation. And if you want to do me a favor, read the documentation, find something that's like, you know, confusing or hard to understand, and just like ask a question in the Telegram group, because that will give us the opportunity to improve it. And then also, like, I think people should try it out. So for example, there's a lot of cool things that could be built, hackathons that could be won, right? So I'd be super happy to like, you know, share all my thoughts on this. For example, like how to build Uber on Bitcoin, right? If someone wants to build this, they can start their own company. I'll consult with them for free pretty much for a while. And I'll just like tell them my idea for how to build it, and they can take it from there. So I'd be delighted to just like, you know, have more people try out the Bitcoin computer. And if they need any help, we're more than happy to try to help. And also, like, most importantly, thank you very much, Kyle, for creating this incredible podcasting series in general, which I really appreciate very much. And also very much, thank you very much for inviting me here.
Well, you're very kind. I'm glad to have the honor to sit with you. And very good, folks. We know where to find Clemens. He's on X at Clemens Ley. Again, check the show notes. You can find the Bitcoin computer. You can find the Litecoin computer. Of course, we're going to promote the Litecoin computer more on this show because we love Litecoin. But he's building for multiple Nakamoto chains, and I think it's interesting to watch and to get to kind of have a chat with you, sir. So I hope we can do it again in real life. Like I said, last month was great, and cheers to a future event. You know, whether it's domestic or somewhere else. But and a reminder, thank you for anybody who's listening, anybody who's supported this show. Please check us out on 84million.com. That's spelled out, no numbers, all letters, 84million.com/podcast. Of course, you can find us on X. You can find us on YouTube. Please subscribe to us on YouTube. We'd appreciate it. And we are grateful for everyone who's already subscribed. So with that being said, Clemens, we'll be watching out for what you're doing. And everybody else, thanks for tuning in today. Have a good one. Bye-bye.